Hey, hi Chaitanya. Hope you can hear me. If you can hear me, just put into the chat that you can hear me and you can see me. I'll quickly share my screen as well. Hey Chaitanya, can you hear me? If you can hear me, you can put into the chat as well. Hi Vamsi. Hello Vamsi. Can you see me and can you hear me?
Hey, hi
Okay.
Sagar. Yes, I can see you and I can hear you too.
Okay. I will quickly share my screen as well. Because we'll need it. Hmm. Okay. I hope I hope you people can see my screen now. If you can, just type in yes. And I will give a 2 minute window for people to join. There are a couple of, I would say, three or four people who have signed up. They should join. If not, then we'll continue. Meanwhile, meanwhile, I would like to ask, what are the expectations uh, of you people from the session? So I have seen in the sheet people have said like want to learn. Somebody has said even want to switch into DevOps. That is also fine. But one of the person was already into DevOps and uh, he wants to switch. Okay. So is there anyone who is already doing DevOps and still, you want to switch? So I wanted to know the context. Like if you are already into DevOps, you want to switch. So what's the reason for it? If anyone would like to talk about it.
Yeah, Sagar. I've been into IT. So I'm working as an sorry, I was working as an IT admin. So I'm pretty much into everything uh, VMware admin or backup and storage. So you can say like L1 support.
Mm-hmm.
Recently, with the reorg structure in our company, so I've been got an opportunity to switch to DevOps. Earlier, I used to do the DevOps, but like very minimal work. So they used to give
Yeah.
build pipeline issues. They used to ask us to debug those because of the resource scarcity. So I was into DevOps, but not end to end. I was not involved, and even though I have got the access, I mean, I was involved, but I was not, got permissions to dig deeper. So with limited access on all the tools. So the currently in last year I got opportunity to move to a full-time DevOps role, where
Okay.
the project I or the product, because my company is a product company. We have many products. Like our company acquired the configuration tool Chef as well. So there are many products. So one of the product I'm working on is using the internal VM infrastructure for the build pipeline, and we
Mm-hmm.
are using the CI tool called TeamCity.
Okay.
So for that TeamCity, we do not have any Docker. Like for other products, we are using the Docker images for the deployments. But for here on the product on which I'm working on, Like they are like purely on the VM infrastructure, and we used to deploy the .war or jar packages to the directly to the customers.
Okay.
So the reason I subscribed for this particular workshop is like, what if, like, in near future, if I got an opportunity to work on Docker, so
Yeah.
I should be having some idea.
Yes.
I've been, trying to learn here and then on YouTube or the articles.
Mm-hmm.
Like, I want to see, like, with the open mind, like what Docker is. I mean, I've been seeing your PPTs as well, a lot of new terms, containerd, all those stuff. I don't know what it is and what are the new features came in the Docker. So I
Hmm.
want to see how I can leverage this workshop so that I get have some idea. Also, I can able to put on the same on my table to the management, like, see, like, I got the Docker knowledge, maybe I can work on it.
Yeah, got it. Nice to know. Hi, Vinay. Vinay, you just joined. So just wanted to know, like, what's the expectation uh, you have from this session? So I've seen people saying that they want to upskill, they want to learn, they want to switch into DevOps role, but someone who is already doing DevOps and still want to switch, I have seen couple of responses there. So just wanted to know, like, what's your expectation from this session, Vinay? If you can unmute.
Uh,
Yeah. Hi.
I, I'm basically from research community. I mean, I'm into AML. The most of the thing we try to build a model and all those things. So I just want to know. I'm completely new to this Docker. Actually, I just want to upskill how exactly the Dockers will be utilized and all those things. I mean, the production and all those things. That's the main thing I'm looking for.
Okay. So I can tell you, like, if you have the expectations that I will directly jump into the production, environment or the setup, it would not be that case. I will go from the fundamentals and then move into the production setup. And still, I will let you know. I would definitely chip in the places where you would need some, concepts to work on the production. But understand, Docker by itself is not production grade. Okay, you would have to definitely go and learn Kubernetes. So after Docker you should go and learn Kubernetes, because yeah, I have for one of the client we have AI ML workloads running in Kubernetes, and definitely I understand that, if you run it in the Kubernetes, you have the, liberty to upscale and downscale the AI ML workloads, right, based on the computation, right? Because if, let's say, 80% of CPU and memory is being utilized, you know that you have to scale the number of workloads. Okay. So I have been in that situation. So just letting you know that, understand, this Docker will definitely give you the fundamentals. Okay. But if you think that just on the day two, right, you do this webinar and attend it, and you would be able to contribute on to your actual projects, I don't think so, but definitely the people who are in your project who are doing DevOps, right? You will be able to communicate with them more effectively. Okay.
Yeah, got it, got it.
Yeah. So, how many years of experience do you have, Vinay, by the way?
Now, I have 6 years of experience. I mean,
Mm-hmm. Okay. So, fine. And Chaitanya, if you can unmute yourself and, just let us know, like, what expectations do you have from the session? If not, then I will, start the session. Okay, looks like Chaitanya doesn't want to speak. No problem. Let's let him make.
No,
I'll
no,
make.
no. Hi, Sagar. Hi.
Yeah, go ahead.
Yes, Sagar. Hi. Currently, I am working in the Android integration. Okay.
Mm-hmm.
And, uh, few, a few months ago, my client they got migrating into the DevOps, such tools like
Mm-hmm.
Jenkins, as well as some of the
Mm-hmm.
Docker related. As the Banu
Mm-hmm.
said, we don't have any permissions to more permissions regarding building side. Okay, some of the DevOps team
Mm-hmm.
is working more than us. So
Mm-hmm.
completely in our company, every project getting migrated into the DevOps tools. So for that, I got a chance to learn Docker regarding Docker. So I have joined regarding this.
Okay.
Yeah.
Okay, fine. I see that most of you want to start learning Docker from basics. That is my also
Yes,
plan.
yes.
But yeah, just I do a quick check with the attendees if anyone is like, they already know Docker and they want to go into the advanced stuff, right? So understand that I will definitely start from the basic. Okay, things can go pretty advanced based on your queries and your questions, right? So anyone who feels like it is going above their head, okay, just ask more questions. Hey, like let's say if I give you some answers, right, and there are some technical jargons inside it, and if you feel like you don't understand that, don't be shy to ask that. Okay, if you, Sagar, you have said this technical jargon, what does it mean, right? So I will definitely go and explain it more in depth. Okay, so shall we start now? You can give me a thumbs up if you want to, interact wherever. If I ask a question, yeah, like let's say if I ask like, did you get it? And if you get it, you can just give me a thumbs up. Okay, so let's start then. And understand, I have some PPTs or presentations with me, but I would say like do check out my LinkedIn, uh, the Dhaansu DevOps page, okay, company page, sorry, not my on my LinkedIn, but check the Dhaansu DevOps LinkedIn page because most of the stuff that I have kept there, right? I would be using that same stuff to basically explain here, right? Like some I have it in this Docker course folder, but some I would directly go to my LinkedIn page and just see like, okay, where is the post which actually described a particular concept. Okay. So yeah, let's open this. So yeah, hope you can see my screen, see the presentation as well. Okay, so before even going, to start with Docker, okay, I will go about what's the underlying tech of Docker. So people who are here, like Vamsi said, right? Like he is into system admin, right? So probably you would have already interacted with the Linux, okay, operating system, or just give me a thumbs up if you have interacted with the Linux operating system. So Vinay has given me a thumbs up. Vamsi has given me. Chaitanya, what about you? Like, understand, like, if you do not give me those responses, I don't understand. Like,
Yeah, yeah, Sagar,
are we on
not
the
like
same
that,
page?
sir. Currently, I'm using the mobile, so some issues regarding of my time.
Uh,
That's why I'm not in.
no worries, but I would recommend, yeah, I would recommend everyone to use laptop because in case if I say, let's say in this session, like, hey, let's try installing Docker. Now, for the person who is joined from mobile, it's like, okay, he can't do anything there, right? So I would recommend that, tomorrow, please do come with the laptop. Okay. So yeah, so let's talk about the underlying tech of Docker, right? Because I said um, it is based on Linux. I just wanted to know like if everyone is aware of Linux. So what are we going to cover in this section is the historical context. If today we are using Docker, why are we using Docker, and what was the historical context? Okay, what were we using before containers, right? And then why containers? Okay, so what is a Docker? Docker runs containers. Okay, so we'll understand what are containers because containers is not only limited to Docker. Container, ecosystem is well beyond Docker, but definitely Docker is the major player there. Okay, and we'll also talk about what are containers actually, and what are Linux namespaces, what are C groups, and why would we need to understand these two items, Linux namespaces and C groups? Because on top of this only the containers have been made. Okay, so using these Linux operating system um, concepts, the containerization is basically set up. Okay, and we'll also talk about the Docker architecture. I might not talk much here. We might need to go to the next section for Docker architecture, but let's see. Okay, and in the end of this section, you can ask me anything. Okay, don't shy away. Okay, we have not covered these things. If I can answer, I will answer. Otherwise, I will let you know that okay, let's take this in the next session, like in tomorrow we can cover it. Okay, so make sure like you can ask me anything. It's not related to, like, you can ask me like career related advice, like you want some career related things also to be answered, like, hey, if I learn Docker, what should be my next step? You can ask that. Okay. So the historical context is this. So earlier we had the traditional deployments. Okay, you had a hardware. Okay, on this you were running operating system. One of the operating, like the typical operating system was Linux. Okay, because most of the servers are on Linux. Only few of them are running on the Windows servers, which are like the .NET applications, right? Because .NET applications require Windows, like it runs better on the Windows machine. So yeah, then you have the Windows servers, okay? But most of them are Linux servers, and then you have multiple apps running on top of it. The problem with the traditional deployment, right, is let's say this app is using Java 1.8, right? And this app is using Java 1.9, okay? And this one is using, like the latest would be like I think Java 21 or something like that, 23. So understand, like now you have to manage 3 Java versions, okay? And how do you make sure that the Java version that is installed for the app one does not, conflict with the another app? So there is a lot of conflicts that can arise if multiple apps are running on the same hardware, okay, and in the same operating system. It can even happen that one of the app requires some setting on the machine which conflicts with the another app, right? So you can't have the app isolation here, right? So okay, that was a problem. And what would be the typical solution is to say that okay, one single app runs on a single hardware, but then understand that particular app is just using 200 MB of storage, right? Let's say 200 MB of RAM, okay? The a particular application is just using 200 MB of RAM, but you have dedicated one machine, and you know very well that you typically would get something like 2 GB, at least 2 GB server, right? So most of the memory is being kind of not utilized, so it is underutilization of resources. So for every new app, right, 200 MB app, right, which needs the memory of 200 MB of RAM, you are allocating a new hardware, right? Okay, that would definitely increase your cost. You could have run multiple apps in the same machine, but then the conflicts, you want to reduce the conflicts between the apps, right? So that was the traditional deployment. Then came the virtualized deployment, where you had the single hardware, okay, and you wanted to run multiple apps. So what you did, you created a virtual machine. What is a virtual machine? I hope everyone knows that. What is a virtual machine? If you know it, give me a thumbs up. Otherwise I will just okay, Vinay said gives me a thumbs up. Vamsi, I hope you understand what is virtual machine. If not, give me a thumbs down. If okay, Vamsi, Chaitanya is also okay. So see, if you do not tell me, that is the thing. Like if you do not interact, I don't know like where do I have to stress and where I have to just skip over it. Okay. So yeah, if what is the beneficial thing in the virtual machines is that in the virtual machine, if this particular app is there, okay, which uses, like there are two apps in the same virtual machines which are using one Java 1.8, and there are two apps which needs 1.9. See, virtual machines are what? Virtual machines are kind of they mimic an actual machine, so they will have their own operating system, right? Both the machines will have their own operating system, all the environments, right? Everything, networks, network related stuff, everything would be different. So an app running on, let's say, port 3000 here, right, can run on port 3000, and another app which wants to use the port 3000 on a different virtual machine can run it, okay? But in the traditional deployment, let's say if this app needs to run on the port 3000, and the another app also was wanted to run on the port 3000, it would have conflicted, okay? And the traditional deployment would not have allowed multiple apps to run on the same port, okay? uh, just a second. Yeah, so that was there. But the problem here is there is some problem here also. Okay, I will talk about it, like I will talk very brief here. What's the problem here? So the problem here is with the virtual machines, right? Every virtual machine bring its an operating system. So you are definitely, see, definitely you are getting the one benefit, which is the isolation, right? You are getting the application isolation. Okay, they are not conflicting with either. But with the isolation, you are also getting the overhead to run the operating system. So understand, if this application just needed 200 MB of RAM, okay, fine. because you have to also run the operating system on top of it, like with it, might happen that just running the operating system is taking 1.5 GB of what memory, right? That clearly means that if I have to run two applications, they might be just 200 MB, 200 MB, but because it's the operating system also being launched with it, it's taking a lot of resources just to run the operating system. Just to bring in that isolation, I'm consuming a lot of memory resources, right? So for example, let's say if there is a 8 GB machine, right? If there are only the 200 MB apps, right? Like all the apps are just 200 MB, and I want to run, multiple apps on this particular 8 GB. So basically, let's say it is, 200. So I can run 40 apps on it, right? But because every 200 MB app would also come with its 1.5 GB, so it would be like something this, right? So I can only run now 4.7 apps, right? Like 4 apps or 5 apps, right? Just because if I'm using virtual machines, because I'm also attaching this part here, right? The operating system. So hope you people understand, like, okay, why virtual machine, even though it solved the isolation problem, but it definitely does not solve the resource utilization problem. I get a thumbs up from Vinay. Waiting for other thumbs up, or see if I don't get any response, I will feel like my I would say like, yeah, everyone gets it. Okay. So don't complain after it. Yeah, go ahead.
Is that hypervisor means, I mean, that VirtualBox VMware kind of thing, right? I mean, those
Hmm.
softwares, right?
Hmm. Okay, so what is a hypervisor? Hypervisor allows, like, see, any hardware, okay, let's say you have any hardware, you have operating system on top of it. Can you run virtual machine on top of an existing operating system? No. You have to have some specialized, software installed, and that is your hypervisor. Hypervisor allows for the virtualization. Okay.
I got it. I mean, even
Mhm.
VirtualBox software, whatever we install on our PC, is that an hypervisor, or the hypervisor is something different, or that is a part of that VirtualBox?
No, it's not part of the virtual machine. The hypervisor is part of your operating system. Okay,
Oh,
so yeah, if you are basically installing VirtualBox, to answer that answer, like, see, there is a lot of details inside it. Okay, but yeah, to keep it simple, yes, if you install VirtualBox, basically you are allowing your system to basically launch virtual machines. Okay, manage virtual machines. But understand, if a machine does not have hypervisor capabilities already, okay, did you get that? Just installing the virtual box wouldn't help you. Typically most of the machines have the hypervisor, like they are hypervisor enabled. Okay, like your machine, my machine, definitely hypervisor enabled. Okay, but you can't expect like any machine on the cloud, let's say, would have this capability to run virtual machines on top of it. Okay.
okay, okay, got it.
So yeah, if you talk about what is virtual VMware and VirtualBox, basically they manage your virtual machines using the hypervisor. Okay, they also manage the hypervisor. Okay.
And if I'm not wrong, that hypervisors are also linked with an hardware, underlying hardware. Even processor has to be, I mean,
Yes.
correct, no?
Yes.
Hardware.
Yeah. Yeah. There are implications to it. Like, does your hardware supports running like virtualizations or not? Did you
Okay,
get that? But that is in like I don't want to get there. Okay, because the focus is on Docker. Did you get that?
okay, okay, got it.
Even I would say, like, on a daily basis you will not need it unless you are doing a very sysadmin job. Okay, did
Okay,
you get
got
that? Okay. Okay, so then that was the virtualized deployment, and we understand the problems there. Now came the container deployment. Container also allows to you to run the apps in an isolated fashion. Okay, so for example, like I was giving an example, like port 3000. So this particular app, if it needs to run on port 3000, it can run it. This particular app can also run on port 3000. This particular app can also run on port 3000. it's not conflicting each other. They can also, this particular app can run on the Java, let's say 1.8. It can, basically we can have Java 1.8 for this app. This can use 1.9, and this can use, let's say, 21. So they have that isolation in place. But do they have running operating system with along with it? No. So that typically means if this app needs 200 MB of, you know memory, it will only consume 200 MB of memory. No operating system is taking any resources out of it. Okay, so 200 MB. So you very well understand, like if there is a 8 GB of machine, I can run 40 such apps if I'm going through the container route. Otherwise, if I go with the virtual machines, I can only run 4 or 5 apps. Okay, so we understand this now, right? Like why from traditional deployment we went to the virtualized deployment, and then even with the virtualized deployment we faced the issue around the resource overutilization, right? So like, you don't need to run operating system just to run a simple Java app, right? So I hope that is good with everyone. Should I go ahead? Okay. Again, now one of the questions, just like, one question was around the hypervisor. Another question could be around like what is container runtime. Okay. So stick with me. We will definitely see. I could have covered hypervisor, but then it does not, like it's a virtualized deployment, right? Like it's a past thing. If you are into virtualized deployment, it makes sense to go deeper into hypervisor. But if you want to go towards the container deployment, right? Understand Docker, containerization. It's better that you invest your time here more, okay? To understand the container runtimes and internals of it, okay? I'm not stopping you to go in depth, but I'm stopping you to don't go in depth of the traditional, deployments. Okay. So that was the historical context. Let's go to the why containers. Now, this I would say like it's a kind of a repeated slide, but yeah, it's give you like just this picture, right? That just this graphic tells you that if you have containerized application on the infrastructure, like say this is your infrastructure, you have host operating system on top of it, and this is your like the container runtime, right? Docker, and you have multiple apps running on top of it. Understand Docker is not the container runtime. Just for simplicity's sake, I'm just saying, Docker is a container runtime, but understand Docker is uh, enabling the facility to run containerized application. Okay. And if you talk about the virtual machines, you have infrastructure, you have also here host operating system, and top of it you have hypervisor. Hypervisor allows you to run multiple virtual machines on top of it, but then you see this guest operating system, they are typically eating a lot of memory and CPU resources. Okay, let's go to the next slide then. So what are containers? So containers are very similar to virtual machines. They help you to bring isolation among applications, right? But they are lightweight. They do not run their guest operating system. Okay. And similar to a virtual machine, container has its own file system, CPU, memories, process space, and everything, and the whole environment. Like it's a different. I would say the network resources that it uses, the compute resources it uses, the uh, process PID, the users that you create in a system, right? Everything is separate. So let's say if I have my machine and I have a user called Saga Moria, right? Let's say that Saga Moria would not be available into my containers, okay? Because the Saga Moria is on the host operating system machine, but not inside the container. So container can have their own users and groups created inside it, and it will not basically conflict with my host operating system. Even two containers will not conflict with each other. For example, let's say if I have a container C1 and I have another container called C2. So let's say if I create a user here Vamsi, right, inside the container 1. So the Vamsi does not exist in the container 2, and inside the container 2, I can create a user called Vinay. Okay, did you get that? Like they are like you wouldn't get any references of Vamsi in the container 2, and container 1 will not get any references to the Vinay user because those are created in the two different containers. Okay, so that is the isolation. That the level of isolation is like at the kernel level, like at the what do you say, the operating system talks to your hardware, right? Did you get that? Like your operating system would talk to your hardware, like hard disk, RAM, CPU. So the isolation is at that level where operating system allows for you know, resource isolations. Like one process, like one container would not be able to get the resources of the another process. Okay, like it will not be like, let's say one process uses some file system, the another process would not be able to, you know, see it. Why? Because it's a part of a different container. So somebody raised their hand. So yeah, please go ahead. Somebody
So,
was,
Saurabh,
yeah.
can we think container is a process and a Docker is a tool to run that process?
Okay. Before going answering this, understand what is a process. Like when we were running the things in the virtual machines, right? I think somebody is trying to join and I can't. Uh, okay. Let me just check it. I will come back to that question. Just I got a ping. I'm just checking one thing. Just a second. Mm, Meanwhile, here I will just go to my company page. Okay. Yeah, sorry. What was the question? The question was around the process, right? Like, see, your question was around the process and the virtual machines, right?
No, I'm just asking in order to define a container. So can we say like container is a process and a Docker is a tool to run that process or create that process?
See, we can say it, but I would not allow you to say it, okay? Because if you say this in the interview, right, that would be a problem. Okay, so if you want to keep it simple and just for your sake to understand it properly, you want to keep it that simple, you can keep it. But the action, like, see, understand, our agenda here is to also, you know, kind of crack the interviews, right? I hope that is okay with everyone. So if you say this statement, right, like if I ask you what is container are processes, okay, and what is docker is to manage the process, right, in an interview,
That's
that
right.
would, yeah, that would be a problematic. Otherwise, yeah, you are right. Okay, and I would like to tell you here, like, why this question clicked me. Understand, everything is process, right? Even in the virtual machines, we were trying to run Java application. What is a Java application? Java application is a process, right? What is your Google Chrome? You are running, you are viewing this, joining this meeting through Google Chrome browser. Okay, what is your Google Chrome browser? It's a process, right? So on a machine, everything is process, right? So ultimately, the end goal is to run a process. How you are running it would be different. Okay, you are running through using virtual machines, then you are running the guest operating system. If you are running it through containerization, then you are getting the benefits of isolations, okay, the process isolation, but also not getting the overhead to run the virtual machines. Okay, so understand, yeah, the containers are basically, the end goal is to run some process inside it, right, but in an isolated fashion and without using much of resources. So yeah, docker allows you to do it, but docker is a complete set of, you know, a docker is a collection of multiple components inside it. And why is it important to not just, you know the surface level, just rather than saying, hey, docker just manages the processes, right? It's better to understand the in depth of docker, and we'll go there. Okay, we'll go there. It just understand that just saying this line that docker manages processes would not get you that you know edge over the other candidates. Okay, So yeah, that was there. Any questions as of now? Are we good with what are containers? Okay, fine. Understand. One more thing I would like to say. Don't think that container is Docker or Docker is container. Container is much beyond Docker. Definitely, Docker is the most prominent tool. I don't disagree with it, but don't say like container is equal to Docker. No, container is much more beyond Docker. Docker has made its adoption very easy. That's fine. Okay, let's go to the next slide then. So the question here is, how are containers contained? If we are saying that we do not need to run a different operating system, okay, a guest operating system, and still the processes are contained and they have their own network and own hardware resources, own file system resources, how are they managing it, right? So it is happening through namespaces and C groups, okay? So I can just tell you that namespaces is allowed for the uh, isolations, and C group is to basically manages the resources like uh, you know uh, disk IO resources, like how much input output you can do for a process to the disk, and then how much memory it can utilize, how much CPU can it utilize, right? So that things are controlled by the C groups, okay? And both these features, okay, are of which operating system does provide these two features? That is Linux. Okay, so containerization cannot happen without these two concepts. Okay, and that two concepts are introduced in the Linux. Okay, so Docker and any containerization tool for that matter, right? There are alternatives to Docker, by the way. So they basically use this namespaces and C groups, and that means that definitely you have to learn Linux. Okay, and I would not, kind of make you scared if you have not yet learned or started learning Linux concepts. I would say it makes sense to do it now. There are many people who you can attend this Docker workshop, right? You can get very good with Docker as well. But if you do not understand the underlying technology and Linux, you wouldn't get much far. Okay. So people who are like, Vamsi said that he has been a system admin. So then he has the advantage over, because he would definitely have a much better understanding of the Linux, okay, operating system. But someone who is coming from, let's say, AI ML background, right? Or somebody as a software developer, right? And they do not know much about the Linux, you can definitely go ahead and start implementing Docker, but you cannot become a DevOps or a pro site reliability engineer. Think about that. Okay, I know Docker, I will just utilize it in my job role, but I cannot switch into the DevOps or SRE. For doing that, you also have to think about Linux, and you have to think a lot about Linux. Okay, I hope this insight helped you to understand that if you want to switch, Linux is the key. Okay, Docker will definitely land you in a job, but in the job you will suffer if you do not understand Linux. Okay, so yeah, so what are the namespaces? Namespaces are a feature, okay, which allows the kernel resources to be partitioned so that one process will see as one set of resources, another process sees a different set of resources. So if a one process sees some file system, some files, another process can't access it. It's not about the code, what is written inside the application. So let's say one application uses, let's say I will talk about like this. Okay, let me draw it. So let's say there's a app one and there's a app two. Okay, if I have a file, okay, called file one, which is intended to be used by the app one, and there's a file two. Okay, so let's say who is stopping a developer to, rather than reading the file one, he can also read the file two, right? Who is stopping it? Like if both the apps are running on my same machine, if I basically make changes into the code deliberately or by mistake, okay, I understand nobody deliberately will use a file which is not intended for them, but by mistake they can do it, right? Like there is a configuration but files, and they are using the file too. So who would stop, like who can stop them to use the file too, is by if you actually say that, hey, your app will run inside a container, okay? And this container only has access to the file 1 and not to the file 2. So even if they try reaching to file 2, their machine, like their container process would say, hey, can't, this file does not exist. So for them it is like, hey, this file system does not exist at all, so they can't, even get to it. So that is what your namespaces means. And there are different types of namespaces. One of this namespaces which basically deals with the files would be a file system namespace. There could be a different types of namespaces. Let's say if I have created some users, right? So if I have some created users, which is, let's say, team city user, right? Like to basically be used by the team city application, and another one is for the Jenkins, right? So let's say if app 1 is the team city app, right? And app 2 is the Jenkins, right? So this app 2 needs only the Jenkins user, right? So if I create a Jenkins user for the app 2, the app 1 can't get to it. Okay, so that is the level of isolation that you get at the Linux kernel level. Okay, it's at the operating system level. It's not just that, just sorry, it's not just that, oh, app 1 is using file 1, because we don't have in the code where it tries to read file 2, we are not able to access. It's not that case. Okay, the case is the app 1 will not be able to see the file 2 at all. Okay, so that was the namespaces. Now what is the control group? Okay, so a control group is, just a second. Yeah, a control group is a Linux feature that limits and accounts and isolates for the resource usage, which is your CPU, memory, disk, IO network. So basically you can say, hey, this app only requires 200 millicores of CPU. Another app only requires 100 millicore of CPU, right? And how much RAM they should use. If they go beyond it, kill the process, okay? Kill the application, okay? Fine. So that is your control group. And it's not that only you can allocate the limits to things, you can also do much more operations using the C groups. We'll get in that in the next slide. Okay. So let's talk about what are the different types of namespaces. Okay. Because you have different types of resources, you have to have different types of isolations, right? So a user namespace. Okay, now I will not go in depth of each all, like, I will not read the slides, but understand that a user namespace has its own user IDs and group IDs, okay, for the process. So one process can have its own user IDs and group IDs associated with it. Another process would not have the access to it, okay? And a PID namespace, if you know, every process has the process identification, right? And it can see its child process. So this is the Linux concept, okay? Uh, a process, okay, can definitely launch multiple child processes, okay? So these are their child processes, okay? So let's say if you are running a process inside a container, right? So it gets its own PID namespace, and any extra process that you run is treated as a child process, and this particular process can see these child processes, okay? But it cannot see a process outside its container, or it cannot see even your host machine processes, okay? It cannot see that. It cannot see that because the isolation is there in place, okay? So that is your process ID namespace, okay? Then comes the network namespace. So yeah, let's say if I have to launch a server, okay, on port 5000, how would I do it? So let's say if I have to do it, I will quickly do it, okay? Python -m. Hmm. So it launched us Python server on port 8000. Can I access it? Let me see. Localhost 8000. Yes, I can access it. It is just giving me a static. It's just a static, server which just gives me all the files that I have here. So now my question here is, if I try to launch another Python server, will it allow me to do it or not? See, I am not running inside a container. It's just my host machine, right? So my question here is to you people, if I try running another Python server, will it allow me to do it or not? That's my question.
Can you repeat the question?
I actually launched a Python server, okay, on port 8000, okay, and it is running. I can see it. If in another terminal, right, in just another window, already I have a Python server running. If I try to launch another Python server again in my machine, will it run or not?
You mean on the same port?
Probably yes. Yeah, on the same port.
Mm, I
No,
don't.
no, it can't.
Okay, it
Unless,
can't.
yeah,
Hmm.
unless, because if you're running on the same OS, you can't.
Yes. So if I run it on the same OS, I can't because address already in use, right? So probably the local host, right? This local host has a set of ports, okay, and each process can bind to a particular port. Okay, so if I have two processes trying to use the same port on my machine, they will not, like, the first one is okay, the second one which tries to get to this port 8000, it will not be allowed, right? But in the containers, right, because you have different set of network namespaces, they get their own set of IP addresses, and they can run, like, within a container you can run, like, if I run these two Python servers in two separate containers, they will be able to use their port 8000. So that is your network namespace. Okay, it has its own, like, there are much deeper details, like, if I don't want to get into, like, okay, what are IP addresses, what are socket listing, what is connection, what are firewall rules, like, but understand all the networking layer details, right, for each container is kind of replicated, and they do not see they are not kind of overlapping with each other. Okay, if you, for the advanced use cases, we can think about, okay, if there is a need where a container A needs to talk to the container B, how do we do it? We will see it later. But for now, understand, like, each container has its own network namespaces, so they can have their own IPs and they can utilize all the ports for themselves. Okay, and there's a mount namespaces. This is for the file systems, as I said. So basically, if I have mounted a host directory on a particular container, the second container would not be able to see that. So that is around the files. Okay, and this is a inter-process communication namespaces. So this allows for, like, the example is POSIX message queues. So basically, it IPC allows the inter-process communication between two processes, and even that is kind of a namespace is created for a particular container. Okay, and also time could be different. So let's say on your host machine, a time, let's say, what is the time on my machine, right? My time is 9:46, but what is the UTC time zone? That is uh, 4 a.m., right, in UTC time zone. So can I, on a machine, can you have two different times for two different, let's say, if I want to make sure that my Java application, okay, uses the UTC time zone, okay, and my Python application uses the IST time zone, it wouldn't be able to, I wouldn't be able to do it. I have to definitely go to my host machine and basically change this settings here, right? Like, in my, I have to change my host machine settings, right? And even then I cannot have, like, I have, if I'm running Java application, I have to change my machine setting to a different thing, and for the Python different. I understand, like, you might say, like, inside the code we can, just like how you did for the date minus you can do it even inside the application, but understand, what about the logging and every bit, like, anything that you do in that container, you want to say that by default let it use the UTC time zone. So on a host machine, on a single host machine, you will not be allowed to have two different dates, okay, in a Linux machine. But if you are running a container, because they even have this Unix time sharing namespace, so both the containers can have their own different timings, okay, and different time zones as well. Okay, so these are the namespaces. So using these namespaces only, a process is isolated. Okay, now comes the C group. C group provide the following feature. One of first we know, like it basically limits the number, limits the resources a process can use. So how much memory it can use, how much CPU it can use. It also, you know, if there is a kind of a contest between the resources, right? Two processes are, fighting for the memory. You can say who gets the more priority. So you can also have this prioritization between the resources using the control groups. And you can also do the accounting. So let's say if multiple processes, so for now, if I want to see, for now, let's say if I want to see how many processes that I have, I run the top command, right? And I can see the process CPU and the memory for each basically process, right? But I cannot say like, hey, this process, a collection of 4 or 5 processes, I should just get like, I should get the accounting for 4 or 5 processes together. So how do you collect those 4 to 5 processes in one group? Is like you create a control group out of it. Okay. So if you have process, let's say PS1, PS2, process 2, PS3, okay, and you basically attach it to a one control group, CG1, right? Now, just by looking at the and you want to basically, once you do this, right, attach multiple processes into a single control group, you can check the total amount of CPU memory being utilized by each by the total number of processes. So basically, let's say this process uses 200 MB of memory, right? This one is using 100, right? And this one is using 300. So rather than checking each process individually, you just want to check, hey, because I have put it into a collection of a control group, right? I just want to check like what's the total memory being utilized by the process running inside this control group. So basically, control group can help you with that. Okay. And then if you want to change the status of the process altogether, like those 3 4 processes which were running within a control group, you want to basically either freeze those processes, stop it, or restart it. You can do it at one shot using the control group. Otherwise, if there are 3 or 4 processes, you had to individually, start, stop, and think about how do you manage them, right? In a collective fashion. So that is your control group. Okay. So are we good with this namespaces and control groups? Okay, Vinay. What about Vamsi? Okay. So ultimately, okay, now if somebody asks you containers, okay, what are containers? Container runs a process. Container is a process. Basically, container is a process running inside an isolated fashion. The isolation is provided using the namespaces and the control group. So if you see this boundary, whenever I'm putting this boundary, what is this boundary? Is it some type of wall? Yeah, it's a type of wall, but not a real wall. It's just a set of concepts which are basically isolating this process. And what are those concepts? Namespaces and control group. So what are containers? Container is a process running inside a particular namespace and control group so that it is running in an isolated fashion. That's all. So I hope that is okay with you people. Like why I'm stressing on this a lot, because many times when people ask you, people when in an interview, when people ask what is container, okay, so what would you answer? What would have been your typical answer? That's my question. Like, do you want to give it a try? What do you like? If somebody have asked you earlier, what would you have given the response? What is a container?
I would have say it's kind of an virtualization technique.
Yes. And what about Vamsi?
I still feel like it's a logical process to isolate or kind of a modern deployment process.
Mm-hmm.
So where we can isolate environments to deploy multiple applications
Mm.
on a single OS or a multiple OS with multiple builds.
Yes, that is so Vinay, what Vinay said was okay. He was just correlating it to the containers, sorry, virtual machines, right? So
Yeah.
understand, that was also not right. Okay. And what you are saying is the object, like the end objective, why we use containers. Okay. Did you get that? Why do we use containers? To reach what you are saying, right? Have the process isolation and have multiple processes running on the same machine, right?
Yeah.
But if you want to, let's say, definitely these questions can, I'm not saying that these are wrong answers, right? But the next question that is going to would have come, okay, that how are containers isolated, right? That would have been the next question in an interview. But if you already are giving the and like in-depth answer in the first question itself, the chances of the next question arising will not come itself. Did you get that?
Mm-hmm. Yeah.
Because I have seen, like I can tell you my personal experience. There were multiple rounds, scheduled 2 rounds of interviews for the Kubernetes like related stuff. Okay, but given that the answers that I was giving was so precise, so technical, right? Or like knowing the like you have a surface level knowledge, but you go still a deeper inside and give those details out, then the next questions would not come at all, right? And that happened with me, where that has happened multiple times with me. Let's say there are 3 technical rounds or 2 technical rounds. It has happened that okay, we don't need to take a further deep down because in the first interview itself, okay, in the first round itself, this person is giving the in-depth knowledge, right? So did you get that? Are you good with that, people? Like, make sure you use that, you give that, you don't, rather than giving the surface level. See, it is still a 2 sentence, right? It's still a 2 sentence answer. Okay. What is containers? Container is a way to basically isolate the process so that we can run multiple processes inside a machine in a isolated fashion. Okay, it's still that much, like it's not, you are not, basically I'm not saying that hey elaborate the answer, right? I'm not saying that hey give a essay out. I'm just saying make sure you use the correct terms. Okay, the correct terms you use will make sure that the next questions in the interview would not arise, and they will definitely go to the next part of that. So if you're, let's say, if your container is not so strong, if you give this answer, definitely they might say okay, let's switch to some another concept, and that you can apply to everything, right? Like if you know in-depth knowledge of something and you give that actual terms, see, an interviewer who is taking an interview of you would definitely know these things, right? Or if they don't know these things, they will be very much, kind of highly impressed by you, right? That, hey, this person knows much in detail, rather than giving the surface level answer, he knows what is happening inside the containers, right? So make sure that you use that technique, okay? That will definitely land you in a job, basically. And I would say unconsciously you do that with what tech stack you are already working. For example, if somebody is already running into the AI ML, and if I ask some question, okay, they will not just say that hey, AI just run some uh, mathematical or scientific equations, and then no, they will definitely talk about hey, we are using this tools and this techniques, and we use this particular, even the algorithm, they will even name the algorithm as well, right? So yeah, understand, like unconsciously as well, if you are dealing with some technology, you give that tech jargons, like you use that details, right? So make sure when you are going, sitting in a interview, right, and somebody asks you what are containers, don't forget to don't forget to mention the namespaces and control groups. That's my only thing. Okay, are we good on this? Yep. Because this is very important. Like yeah, I can definitely in Docker there are so many things, right? Like, but if you don't get this, you are still on the, basically with everyone, right? You want to make sure that you get, like if there are 500 applicants to a job, you want to make sure that you get selected rather than the other 499, right? So yeah, make sure, like this is one of the interview cracking tip, I would say. Okay, uh, let me go to the next slide now. So one of the major question that arises, right? Docker is relatively new. if all the things are already there in the Linux, right, to create a containerizations, right, the namespaces and the C group. So why we don't hear about the containers before Docker? So understand? Yes, containers were pre-existing from Docker. Okay, so there were already containers running, and they were called LXC Linux containers. Okay, and it was released on 6 August 2008. So it's a long time back, right? You are hearing containers, I think, around 2015, 2016, but understand the technology was already there. It was already launched in the 2008. We'll talk about why did not it pick up, or why did not it get the boost. But for now, understand, like, we want to make sure that we understand that Docker is not the only way to run containers. Okay, so LXC is a user face interface for the Linux kernel containment features. See, Linux kernel containment features. What were those? Those were namespaces, and those were the namespaces and the C groups, right? And using an API, right, it allowed the Linux users to create the containers. So basically, still they had to, kind of code a bit. I would say they had to use that APIs to basically create a control group and attach process to it, controller namespaces and attach process to it. So it was a bit of not so easy to do thing, but still it allowed you to run your process in a contained fashion. Okay, and LXC is a free software, so most of the code is under this GNU license, which is open source and free to use. And more details, like, it's not that LXC is dead now; it's still being used. Like, if you want to take a look at it, you can take a look at it. I will not say that, hey, go deeper into it, but yeah, if you are interested, you can see it. Like, definitely, it has grown to a lot now. What was there in the 2008? Okay, so now the question here is, okay, if LXC was already there, wow, what is Docker then? Like, how did the Docker came in? Like, when LXC was already there, why did the Docker came in? So understand, Docker, when launched, was using LXC itself. So basically, it was not directly interacting with the namespaces and the C groups. It was using the LXC APIs itself. So basically, Docker, to run the process in a contained fashion, was actually built on top of LXC. Okay, so it was released on 20 March 2013, which means 2013 minus 2008, right? So 5 years have been passed after launch of LXC, then the Docker was released, right? And at the time, it used LXC, right? It's a default execution environment, and Docker is written in Go programming language. Now, this part, why is it, like, why do I need to tell you, like, there are so many tools, right? Jenkins must be written in some language, like it's in Java based, TeamCity would be in different, and AIML things, right? AIML tools would have been written in some different programming languages, right? So why, like, should we care about it? I would say yes. Okay, so why we would care about it? Understand, when Docker is written in the Go programming languages, right? Most of the tools around Docker, Kubernetes, Prometheus, like so many, I can, like, there are so many tools around this Docker ecosystem and Kubernetes ecosystem, containerization ecosystem, which are written in Go programming language. So as a DevOps person, okay, or as a SRE person, it makes sense if you try to also learn this Go programming language. Why? Because at times there are tools with limitations, right? You have the limitation where that tool does not provide you some feature out of the box. Now you want to extend that, tool, so you can start writing your own Go program, like, you can code for it, right? So just letting you know that it's not a prerequisite, or it's not mandatory to learn Docker, that you have to become a Go programmer. But yeah, most of the DevOps or SRE person are switching. Like, say if they were using Linux programming, they were using Python programming, they are shifting towards the Go programming language as well, because the tools that they are interacting with, Docker, Kubernetes, if they have some limitation, they have to, like, if they want to dig deeper, one level deeper, they have to understand Go programming language and code for it. Okay, so a lot of, like, if these tools are open source, Docker, Kubernetes, and all the other, Prometheus, Grafana, understand what is the community using the like, which community is able to contribute to it. It's the Go programmers. Okay, so Yeah, Docker is there. Linux was Alexi was already there. So on top of this low level foundation of the Linux feature, Alexi, Docker offers a much better, higher level, functionalities. Okay, just rather than just running, able to run the containers within a isolated fashion, it provides much more functionalities. The details are here. Now let's see. This details was here, but recently, okay, they actually removed, like if you see this dockers docs.docker.com engine FAQ section, right? So recently they have removed this FAQ section altogether, right, from the Docker engine overview. Earlier I had that FAQ where it told me, okay, does Docker technology add to just like what does Docker technology add to the just plain LXC? I think I would get some snippet from the past. So this, right? So where is uh okay? They would have okay. They have actually even recently Docker has also put the blog LXC versus Docker where they have yeah. If you see the state June 13, 20. So relatively newer, right? So yeah, where they have talked about see key features of LXC. Yeah, this was the two key features, right? And benefits of LXC, you are able to use lightweight. But what about Docker? Like what does Docker brings in? So Docker enhances LXC, okay? And the key benefit is Docker allows you to, if you have a container, like a process running in a contained fashion within your machine, right? You can lift and shift to a different machine. So the portability was there. Then it's a ease of use. LXC relied on the APIs, like kind of you have to still, run a kind of a configuration, right? In Docker, it's just Docker run command and you are able to run any Docker, like you are able to run a process in a contained fashion. And there's a vast ecosystem. You do not hear LXC a lot, but Docker you have heard a lot. It like Kubernetes relies on it. You also like any tool that you want to install, people say, hey, here is the Docker image for it, right? Hey, Docker run command and you will get it. So there is a lot of vast ecosystem on top of it. Okay, so understand Docker is a enhanced LXC, and understand this as well, that um, at that time, like when it was first released, this was using the LXC. Now does Docker now uses the LXC? No. Docker directly now interacts with the namespaces and the C groups. Okay, it does not uses LXC in between. Okay, so when it was first launched, it was using LXC, but now it directly is interacting with the namespaces and the C groups. Okay, so yeah, that was all about this section. Okay, so if you have any questions, you can ask me now, like anything for that matter. It's not related to Docker, definitely related to DevOps, but ask me anything now if you want to. I can give I can launch a timer. Let's launch a timer for 10 minutes. I'm giving you a 10 minutes window to ask me anything. After that, we'll take a 5 minute break or 2 minute break, whatever suits you, and then we'll get back to the next section. Okay. So yeah, please utilize this 10 minutes or either or I will just, directly jump to the break and we'll come back later. So what do you people say? Do you have anything to ask me?
So you mentioned right now Dockers are not using LXC, right? I mean, does it mean that they're directly utilizing the Go language? I mean,
Mhm. See, Docker was also see Go language was already there. Okay, using the Go language, what they were interacting with. So let's say if I say this is a Docker, right? It was written in Go programming language. Okay, at the like when it was launched then also. But how was Docker running the containers? So this is a container, right? How was Docker running the containers? You very well know that to run containers you need namespaces and control groups, right? So was Docker directly interacting with the namespaces and control group when it was initially launched? No, it was actually going through LXC. It was making the LXC calls, and then LXC was basically managing the namespace control groups to run the containers when it was first launched. And now it directly uses the namespaces and control groups. Okay. But the Go programming language was still there. Like Go programming language was used to first interact with the LXC. Now it is basically directly using it to interact with the namespaces and control groups. Okay. Any further questions you have, people? Please ask. Feel free to ask anything.
I don't have any further questions.
Okay. Uh, Vamsi, do you have anything? Otherwise, we can, take a break.
Nothing for now. Maybe I can ask later.
Mm-hmm. Okay. So then I would suggest that we have 7 minute window. Okay. So see, it's a 3 hour session that we have. So I think we can take a break every hour, right? Yeah, because otherwise, it's very hard to focus. Cool then. Let's take a break. I will stay on mute and 7 minutes window. Do whatever you want to do. Come back at 10:16. Okay. Hello. Hi everyone. Can you hear me? If you can hear me, just give me a thumbs up. Also, I will know like you people are back. So looks like one. Okay. Yeah. So two people are back, and there are only two people right now. So yeah, let's get into the next section. Okay. At least now you know if somebody asks what are containers, what you need to tell. You can tell like when Docker was first launched, it was using LXC, and then later it went to using its own and interacting with the names. All these details when you add it into your answers, right? This I don't think that you won't get a job then. Okay, if you add this level of details in your answers. Okay. Other than that, yeah, I know like the next steps are very easy. Like the next things that are there, which are like, okay, how do you launch a container? How do you stop a container? How do you check the Docker images? Right? All those trivial things. But these things, which I have covered in the initial slides, those will let like those are the first set of questions that you would get asked, right? And if you actually tell these namespaces, C groups there, okay, then the trivial questions, right? How do you run the Docker container? How do you stop a Docker container? What is a Docker image? All those questions will vanish, right? They will go away because if somebody sees that you know in depth of Docker this much in the first question itself, there's a high likelihood that they might just say that, hey, you are selected, right? We don't need to ask any further questions. Yeah, for formality purposes, like if it's a 1 hour interview and they have a set of questions already in hand and they have to make sure they ask each and every questions, right? If they just want to go very bureaucratic or formal, they are very formal driven, then fine. They might still ask you question, but at least if there are any interviews which are happening very ad hoc interviews, or the interviewer panel itself is a DevOps, right? And he says that I just want to make sure that this person can do the thing or not, then it's high likelihood they would not ask further questions. Okay. So that was the first section. Let me go to the next section, which is let's see, what is this? Getting started. Okay. So let's get started with Docker. Now my question here is for you people. What is the first step that you do to get started with any tool? There's a question to you people.
Visit website, see the user manual, and
So can you tell me any tool you use for AI or ML?
anyway, TensorFlow, that is a tool to train
Mm,
deep learning models.
so do you have TensorFlow on your machine?
Right now on my desktop, I don't have. I connect it through desktop.
Yeah, but to
In my,
your company or wherever you work with
yeah,
the work laptop, you have it.
I have.
So what about Vamsi? Vamsi, what do you want to say?
No, I mean, says like, uh, come again with your question. Like you're just asking, like, how I going to install a software on a machine?
No, but yeah, and the answer would have been the same. But yeah, I was saying like if you want to learn any new tool, what do you do first?
Okay, so I won't. I'll try to how I do it. Like, just go to site and see like how I can install, run a couple of commands and study like what that command will do, what exactly it going to do, and what is the use of it.
Mm-hmm.
I'll try to understand the basic of those process of using those commands, what it will do, why we have to do it, where exactly when we have to do it. Then
Mm-hmm.
later on, I'll try to uh, you know implement or add more complexity to those commands uh, with a lot of arguments or options and see
Mm-hmm.
what exactly I'll do. Then I'll have a better understanding. So I'll be doing everything on a machine. Like I'll study very less. I'll try to have a basic understanding and I'll get my hands dirty on it. That's it.
Yes. So yeah, and I would say that is true for everything. Uh, so first thing that we need to do is to install Docker on your machine. So anything that I'm going to do late now onwards, right? I would be running commands on my machine and showing it to you. You might even get the recording as well, okay, from this session. But still, I can tell you, I can guarantee you, if you don't install Docker on your machine, you're not going to run any Docker commands on top of it, then you wouldn't learn at all. There are many YouTube recorded versions. I do myself put some videos on the my YouTube channel, but I can tell you, like, whoever goes and views it and without actually practicing on their machine, they would not get any insights or any learning. So make sure that you install Docker on your machine. Okay. Uh, if See, if I hear, like, okay, I understand there are many times it has happened with me. People have given me I would say reasons, right? I will not say excuses, but they have given me reasons as to why they have not yet installed Docker on their machine, right? So let's say tomorrow, if you come, I would highly appreciate that you have the Docker installed on your machine, uh, so that you can ask any questions, right? Like, you can ask much better questions rather than just running the Docker commands, which you can anyways get it on online. Like, you don't have to attend this session for it. Okay. Is everyone good with this? Like, you need to install Docker on your machine and come tomorrow. Okay. Because even it can happen that you are not able to install Docker on your machine. My machine is what? My machine is Mac OS, Apple. The way to install Docker here, or the challenges that I had faced to install Docker on a Mac machine, would be different from the Windows machine or Linux machine, right? So if I'm able to run Docker commands, doesn't mean that you will be able to run Docker commands on your machine, right? So make sure you go ahead and install it. Okay. I would basically, it's if you don't do this, I don't think like any further, like whatever I'm going to teach you later now, it's like, it's not of no use if you are not going to install Docker on your machine. That's what I have. Okay. uh, Simple. So okay, what are we going to cover in this? So first of all, we'll cover the Docker architecture. Okay, how Docker is, architected. Okay, and we'll also containerize an application. So basically, if I have a Python or Node.js application or Java-based application, let us see if I can containerize it. Okay, I can run it. Can I run it within a container? Okay, and we will also create multi-container apps. So you people know, right? Like, you have like, if you have application, right, it can have multiple set of apps to basically, do a particular thing. So for, let's say, AI ML related stuff, right, you have multiple AI ML workloads, right, that will collaboratively work and give you the final output, right? Is that right, Vinay? Like, you have multiple algorithms, multiple, like, one of the AI ML workload would run in Python, the other one would run in Java, the other one would have been written in TensorFlow. Okay, I'm not into AI ML that much, but yeah, mostly I've seen R programming languages used in AI ML related stuff, and data science stuff, data engineering, and yeah. So typically, even for a website, right? Like, a website would have a front end application, right? A front end application which will just give you the HTML pages, the browser pages. Then you would have a backend server which will basically do the business logic, if else and everything is here. Okay. And then there is a database, right? So basically, you can see there is a front end. We might have to run a front end application and a back end application, right? So can we run it within a container, and how to do they because when we said containers, we said they are isolated. So if front end needs to reach out to the back end application or container, how would it reach? So we'll also see while we do the multi-container apps. And typically, I will say, in any organization, if you have heard the microservices term, it's the multi apps setup, right? Now, multiple apps you don't want to run inside the same machine, so you create a multi-container app. So microservices were pre-existing. Docker or containerization has just helped it to get adopted very quickly, right? Okay. Otherwise, to run 40 applications just for the sake of running microservices and using the resources and having the infrastructure, it was very painful. But coming, like, containers, like, now when you have containers, it's very easy to basically go with the microservices architecture. Okay. And we'll also talk about Docker Compose. So Docker Compose actually enable the multi-container apps in a much better way. Okay, so if you have multi-container apps and you want to run it together, okay, in a better operated and better managed fashion, you can start using Docker Compose. And I would say if you install Docker, by default you also get the Docker Compose installed. Okay, Docker does not just only installs Docker, but it also install you know uh, uh, other tools as well, which it is like they are bundled together as of now. Okay, and later at the end of the section you can ask me anything. Okay, first of all, let's talk about the architecture. Okay, so Docker architecture is comprised of three major parts, which is client, Docker host, and registry. Okay, what is a client? To interact with containers, you have a command line utility where you run, docker build, docker pull. Okay, does the Docker container needs to be on the same machine where the client is? No, the Docker host could be on a different machine. So the containers could be on a different machine, and a person who is interacting with the containers could be on a different machine. So if you see this, understand this is a different machine. It can be same machine as well. That's not a problem, but it can be a different machine as well. So there's not a need to have the Docker host and the Docker client on the same machine. And the same is true for the registry. The registry where the Docker images are. We'll talk about Docker images further, but understand Docker images are the blueprint to run the Docker containers. So Docker registry could be at a different place. So understand that right now when you install Docker, all these three components gets installed directly onto your machine. Okay, so you have registry on your machine, you have Docker host on your machine, you have client on your machine, right? But that is not the typical uh, deployment on actual production use cases. So your Docker host could be the actual servers where the containers are running, and the client could be your machine because you are interacting with the Docker containers. And the registry could be like JFrog Artifactory, right? Have you people dealt with Artifactory, any Artifactory, Nexus Artifactory, JFrog Artifactory? Vinay has not dealt with it. Vamsi has dealt with it. So Artifactory are places where you can keep your jar files. Okay. So let's say when you are for AI/ML related stuff, if you are using Java and you are installing jar, right? Or if you are basically installing some Node packages, Node.js packages from npm. If you want to install some Python packages, Vinay, I hope you would have installed some Python packages or Python code
Yeah,
base.
yes,
Hmm. So you would have run pip install something, right?
yes.
So pip install something is the URL that something URL is the URL of the registry where you have Python packages. So just like how you have Python packages for Python related stuff to run containers, you have its images. So if I want to run Nginx image, I want to run TeamCity container, I want to run some Python container, I can find an appropriate image on the registry. Okay, and we'll talk about it later, but now for simplicity purpose, why I need to show you this Docker architecture is to make sure that you understand Docker client, Docker host, Docker registry need not be on the same machine. Okay, but if you install it for your developer setup, your local machine setup, it will be on the same machine. Okay, so let's talk about the different components. So one of was the Docker daemon. So Docker daemon is actually that thing which is managing your namespaces, control groups, and running containers. Okay, and it also manages other Docker objects such as images, containers, networks, Docker volumes. We'll come to this later, but understand like this is the main part which is running the containers. A Docker client is just to basically enable the Docker manager, like people like us, to interact with the Docker daemon and tell it like which image to run, which container to run, which networks to create, right? And this happens over the network. Okay, it could be a socket network, it could be any network interface, right? Like HTTP based or socket. Like mostly it is socket based. Okay, so I will not go into the socket networking a lot, but understand like it's mostly the Unix sockets or a network interface. It can even happen over HTTP and other, you know, uh, network interface. Okay. And then Docker Desktop. Docker Desktop is an easy to install application for your Mac, Windows, Linux, and it comes with Docker daemon, Docker client, Docker Compose, Docker Content Trust, Kubernetes, like a lot many things, right? So you can, for more information, see Docker Desktop, and that is you have to do, okay, before you come to the next session tomorrow, okay. So let's try to containerize an application. So I have a repository. Now, this is a major question. How many of you have already dealt with Git? So have you dealt with Git or not? That's the question. Give me a thumbs up if you have dealt with Git. Vamsi, what about you?
I already gave the thumbs up.
Okay, I didn't see that. Okay, fine then. Uh, so I have a Git repository with the code, and yeah, it's a Python code. And if I want to install and run it, I can definitely check out. So now this is also for you people. Most of the times when you are reading anything like Docker, any related technology, make sure that you go to the GitHub and check appropriate. Like there would be people who would have been giving the YouTube videos, like learning YouTube videos, but they would also have mentioned in the YouTube description that, hey, if you want to check out the repository, it's here. Make sure you do it, because it's, again, if you see them doing it over the YouTube videos, fine, you can understand it, but then it is you who has to practice. So you can definitely go and check out those codes. So let me check out this code, right? Let me do it in a temp directory. Okay, I have this code. If I have to run it, how to do it? So understand, with the Git repository, everybody gives a readme.md file, which is like, anybody who is using this Git repository should read this first file, and make sure when you are also creating some repository, you make sure that if a next person has to run your application, how do they need to run? You should have those details in the readme.md. So it's like, okay, Python 3, I will do this stuff, right? Okay, and then they say do this, and then I do this. Okay, and the last part is to run the Flask. So it's a Python Flask based application. Fine, it's running good. So if I try to open this, it's a simple application, just hello world, right? Can it do this thing? Can it do user server? Can it greet me? Yeah, it can. It is not just a typical hello world. It is definitely a bit advanced, which it is able to say hi to me, say hi to Vinay, right? Say hi to Vamsi, right? Okay. Uh, can I run it again, like in the another terminal? Okay. If I run this again, uh, I might have to, again run those commands, I guess. See, port 5000 already in use, right? So that thing which I already had told, like, okay, a single port can't be used here. So what I would do, I would like to, run multiple versions of hello world, okay, and rather than changing the port, I can definitely change the port, but then understand, you don't have the liberty to change ports for all applications. Let's say if Jenkins is coming with the default port 8080, right? Now in every, like, in some applications you can change it, they will give you a way, but then there could be some applications which is say, hey, this is the default port, uh, run on port 3000 only, and to make that port, basically, to change that port, you have to do a lot many things rather than just changing a line. So yeah, so I would say, like, in this context, I would like to run this Python application within a container and run multiple versions of, like, multiple containers out of it. Okay, so first of all, to run a container, right, I have to containerize it. That means I have to, if I have to containerize it, I had to create the namespaces, I had to create the control groups, right? Are you good with this? But understand, if I have to create namespaces, if I have to create control groups, if I have to attach this application there, it's a lot of work to do, and that was what LXC was. And that is where LXC is not a LXC is not trending today, right? And what is trending today is Docker. So Docker allows you to basically, if you want to run a container, create a blueprint for a container. Okay. So Docker says that if you want to run a container, okay, you don't have to tell me like what is the process, what is the C group, what is the namespaces. No, no, don't do these all stuff. Just create a Docker image out of it. Okay. Just create a Docker image out of it. In that, you tell me like what is the process, okay, what is the command that it needs to run, what are the files it needs to use, what is the port that it should listen to, right? Expose some ports, right? Tell me these details, and managing the namespaces and control groups, leave it to me. I will do that. Okay. So Docker says create a Docker file and then do a Docker build. So basically, you have a Docker file. So it says in the Docker file, describe whatever you need to run as a part of container and build it. You build it and you create a Docker image out of it. And once you have the Docker image out of it, you can give it to the Docker and it will run it as part of container. Okay. So what is a Docker image now? Docker image is the blueprint of what needs to be run inside the container. Otherwise, you had to do all the plumbing yourself. Okay. Is that good now? Okay. So let's see the Docker file. Okay. So this is a typical Docker file here. And if I compare it with what readme.md has, okay. So if you see here, I have said Python, like there were some steps involved to basically get to this, right? So all those steps are written here. So first of all, we are saying that from Linux AMD 64, like because I want to run a Linux container, okay, that is where the platform is, and get me the Python latest Docker image. So I don't understand. I don't have to even install the Python on my host machine, because if I am using container, I can say, hey, use this image. Okay. So this image will get fetched from the registry, which is on the cloud, which is called hub.docker.com. From there, it will get the, you know, the image. Okay. And then I'm saying that copy this requirements.txt, which is on my machine, okay, host machine, inside the container. Dot is the current working directory. Okay. Linux concept. Okay. So it will do that. And then I will say pip install -r requirements.txt, which we were doing it here, right? And then also copy the hello world.py, because that Python file is required. And then rather than running the Flask, Flask hyphen app, I'm using waitress hyphen serve. Now you might say like, why aren't you using Flask, right? Understand, Flask is not like to run this application in this mode. It's not if I run it here itself. Let's see. I will show you. It was showing me. Okay, if I run it here, see, this is a development service. Do not use in production deployment, right? So yeah, fine. If you are running it on your machine, you can run like this. But if you are thinking to basically create the image and run it for the production grade, you have to think about like, okay, to run a Python server Flask app for production grade, what do I need to use? So this is what people mostly use. So I've used the same. Okay. And now if I have to, because if I have this Docker file, okay, you would see like I am missing one step, right? That sorry. So one step which is like this, Python minus me m virtual environment env and then activate, right? Activating that virtual environment. In Python context, okay, you need a virtual environment if you want to isolate a Python process or application. Because I'm going to run the Python application itself in a Docker container, okay, in a containerized fashion, I don't need these things, right? It's needed only if I'm running it on my host machine. But if I'm running it inside a container, that is container itself is taking care of the isolation. So I don't have to create a virtual environment and activate it. Okay. So that is there. Now, if I already have the Docker file, right? Okay. So Docker says that using the Docker file, you can create a Docker image. So to do that, Docker, you have to build it basically. Docker build. Okay. Where is the Docker file right now? It's in my current working directory. Okay. Let me run this. You can see it is running some things, right? So what I will go through the logs, we'll go to the logs, is that first of all, it requires it kinds of reading the Docker ignore file. We'll come to this later, but if you have already doing Git, so you know what is .git ignore, right? The Docker ignore is the similar kind of thing, okay? And then it also, kind of fetches the Python image from the docker.io library. Okay. And now if you see 1 out of 4, which is like the getting the first image, and I can also show you Docker file. Okay. So if you see here, there are 4 things to do. Okay. So one is that to use the base image, then is to copy, then is to run this. Okay. And then is to copy this. And what about these 2 things, right? You might say, if there are only 4 things to build a Docker image, what are these 2 lines? So first, this line does not basically run anything inside the image. As a image building process, it does not do anything. It just tells the intent to anyone who is basically going to use this Docker image that, hey, on port 3000, this particular service would be exposed. And this is the command, right? Like this is the command also here, like which is not being part of the build. What does it do? See, when you are building the Docker image, you do not run the application then. Okay. It's the image when run, it's the image when it will run as a container, this particular command would get executed. Okay. So this is the process that gets executed within the container. But to build that container, you need so many things already, right? Like if you run this command within a container, you first have to think about, hey, is the Python installed? Is the my Python source code available or not? Is the waitress serve is installed or not, right? So all those things has to be pre-baked inside the image. Then only this command will run as a contain, like in a contained fashion, right? So are we good with that? Like you understand now, like okay, Docker image has all the prerequisites to run the command that it will get executed inside the container. So basically, if I have this image now built, if now basically I use this image to run a container, right, within a namespace and control groups, Docker will run it inside a container. But what is the command that it will run inside the container? It would be this command. Okay. It will run this command. And that is where this command does not get executed as the part of build process, but all the other above ones get executed. And expose 3000, it's a special, just a directive, or it just says it just is used to provide an intent to whoever is using the Docker image that, hey, probably the service would be listening on the port 3000. Okay. So so if you see this one, first step, it is basically getting the image. And then where is it? Then if you see 2 out of 4, it's a copy command, right? This copy statement, which is copying requirements.txt from my host machine to the within the image. Okay. And if it is inside the image, it will be also present inside the container. And then it is running this install requirements, and then it is copying my hello world.py to the container. Okay. So if I have this Docker image present, can I see it? Docker image ls. Okay. So Docker image ls gives me the container that I created just 2 minutes ago, right? Okay. But the problem is, do I see any name of it? No. Why? Because while creating the image, right, you also have you should basically, you don't have the flexibility or the this feature. It's like, hey, you should do that. You should always name whatever you create, right? So let me call it as hello world version 1.0.0, right? Because this is the first version. Okay. So I'm creating this. You see this, it got executed very quickly. Why? This build process was very fast because most of the things it knew that did not change from the, you know, the previous existing Docker image. So it did these things from the cache. So basically, whenever you build Docker, right? So it keeps some things, Docker layers in the caches. Okay, we'll talk about that later. But understand, yeah, a subsequent run Docker build, like a subsequent Docker build run, might not take the full time, right? Let's say the initial Docker build took 1 minute. Okay, the next Docker build might take only 3 seconds, right? Because see, already this Docker image was already pulled, right, from the internet for the previous uh, image creation, right? So it did not need to basically uh, re-pull the image because it has kept the image locally in the local registry. Okay, so if I say Docker images now, so you see this hello world version 1.0.0. So if I want to run this Docker image, what do? I say Docker run and the image name is hello world and with the version 1.0.0.
Uh,
Go ahead.
Hello.
Yeah, go ahead.
Yeah, previously you build in Docker without the tag and repository name, no?
Right.
Where does it overwritten
Yes.
or new
Yes.
image?
Yes, it got overwritten. I will show you. I will show you that later. But understand that a new image did not get created. Existing image was tagged with the name. Did you get that?
Okay,
So
okay,
when you run Docker build, so Docker build dot would have created an image, but the image already existed with the same Docker file and everything in the hello world.py and everything nothing got changed, right? Did we change anything, a single line in our application? No. So basically it used the existing built image and tagged it with this name. Okay.
okay,
And that is where you see 4 minutes ago. Did you see this? Like it is not 2 minutes or 1 minute ago, it is 4 minutes ago. So it's the initial image that we created. It just got tagged with this, hello world and version 1.0.0. Okay.
okay, okay.
Yep. Now if I run Docker run hello world. So yeah, fine. It is just giving me some warning. That's fine. But can I access it? No, I can't. Why? Because see, when you run Docker run this command, it is basically contain. See, the application is running definitely on the port 3000, but it is not exposed to your local machine, host machine, right? For that, you have to do the port for publishing or port forwarding, whatever you want to say. But you have to say like port 3000 on my local machine goes to the port 3000 to the container. Okay, so where is it? Okay, I think you have to give it here. Now this is very crucial. Make sure the order matters a lot. Okay, so 3000 and then the 3000. Hmm. Now let's see if it works. See, now it works, right? Now it works. If I even try to do localhost, see, it works. Okay. Now you might say like, okay, fine, we have it. So I want to run again, Docker run, but this time if I do it, it will create a problem. Already a container is exposed on the port 3000 on my local machine. If I do the same, it will not allow. So probably what I would say, hey, there is an existing container running on the port 3000. I want to run this application again, but use port 4000 on my local machine, right? So now this will be a localhost 4000, right? So you have multiple versions of the app running on different, ports. So this can be allowed using the Docker container. Okay. Now, yeah, there was a question that you asked about the images. Okay. So for the images, I will say, whenever you create an image, okay, it creates an identifier to it. It's not the tag, okay, that you are, this tag is for your purposes, right? But Docker does not store it as part of tag. It actually store it as a Docker images container image ID, sorry, image ID. Okay, not a container ID. It stores it as a image ID. Now, if I run the Docker build again, okay, with -t hello world app, and I will tag it at rebuild. See how fast it did. And Docker images, if I see the images, you see both the image ID is same, right? Hello World rebuild and version 1.0, and both are created 8 minutes ago. It's the same image but with a different tagging. It's like a, there are, what are tags? Tags are just a reference to what? To an image. Okay, an image can be referenced by multiple tags. Okay, did you get that? Image can be referenced by multiple tags. So multiple tags can reference the same image. So yeah, it's that the case. And that is where it got completed so quickly because most of the things is used from the cache. Okay, is this clear now? Okay, so these are your Docker images. Okay, now, so I only ran one image, right? Like I had one hello world and that's all I ran. What I want to do next is I want to run multi-container apps, right? Because typically you would not run just one container, you will run multiple containers, and those two containers would need to interact with each other. Okay. So before doing that, do I have any Docker containers running? No. Do I have any Docker images present? Yes. Do I want to delete it? Yes, I want to delete it just to make sure that we are not creating any confusion going forward in the session. Okay, that's why I want to delete it. So Docker RMI, it's RMI means remove image, and then I just have to, rather than giving the tag, I can also give tag hello world version 1.0.0. Okay, see, it did not remove the image, it just untagged. So that means the image still exists, but it, because see, multiple tags were referencing the same image, so it couldn't delete it. But if I delete it now using the rebuild, it will untag and delete as well. Where is it? Why does it say this? Oh, sorry, my mistake. It's underscore there. See, there's a problem. When I try to remove this image, okay, it says that it is unable to remove this because one of the container is using it. Do I have any container running? Docker ps is the command to see any containers running. No, I don't have any containers running, but the containers that I ran is still there and it is referencing it. So if you want to see Docker ps minus a, all the containers, whatever be their status is, so you will see there are many containers which I created, and they got kind of, then I stopped the process. So if you stop the process, the container dies, but still it is referencing the same image, right? The image ID. That is where it is not allowing me to delete the image. So what I would do, I would say Docker rm. Okay, I have to remove these containers as well. So these are the containers I see, right? Now understand, I would not be doing this. I will just say ps minus a and minus q. Q means quite, like just get me the ID. So all these are the container IDs. So what I will do, I will just say Docker rm to remove all the containers. Okay, whatever the Docker ps minus a q gives. So whatever this command outputs, I would basically remove those containers. Okay, this is a Linux, way of basically command substitution. But yeah, understand, as a DevOps, mostly you will use it. You would need these things going forward, and a Linux knowledge, a little bit of Linux knowledge never hurts anyone. Okay, so now if I have the images, I have all the containers, uh, removed, right? Be it dead, be it running, all are removed. So would I be able to remove the image? Let me see. Okay, Docker ps, Docker images. No, none images, no images now. Okay, so we are good. We can start clean. Now, before I go to the next section, I hope you understood, like, you saw running so many commands, right? You have seen me running so many commands. And like understand, if you do not pay attention, and that is why I give breaks, if you do not pay attention, most of the stuff would go, like you would not able to focus, and it will go, it's like it will just skip, right? But understand, it was not the things that are, and understand that I would not be able to teach you something, okay, just like with the images, this image ID and tagging bit, and I was not able to delete the image because one of the container was using it, right? One of the container was using it, uh, and it has the reference, and the container was in the exited state, still it had the reference. So all these things I can't teach you unless I get my hands dirty, right? Otherwise, I can always have a beautiful presentations, okay? But then nothing will like you will just go and see, okay, fine, this is something talking about something, but why does it matter? It matters when you do stuff, okay? So fine, we have basically created our container, we have done it. We have also seen that what are images? Images are the blueprint to run the container. And what are the, when you build a container, what are the steps to be run and what are the steps to be left to when the container would run, right? Like so one of the steps that we have in the Docker file, for example, command step is not run when during the building process, Docker image building process. It runs when you run that particular Docker image as a container. Okay. So now let's see multi-container apps, right? Because that would be a typical. So you see this container networking. So if you remember, I said that the containers are isolated, right? Using the container network namespaces. But in case you want to make two containers talk to each other, you have to make sure they share the same network namespace. And to do this is this way. Okay. So I can create a Docker network create to do app. Okay. So let me create this. So what it would do, it will create a network. If you see, there are so many networks, right? The one of the networks that I created was to do app. Okay. So we have to make sure whatever containers that we now run, okay, they are basically launched in the same network, to do app network. Otherwise, they will not be able to communicate with each other. And what does the network do? Like, what is a Docker network? Docker network allows you to run multiple containers within the same shared network namespace so they can communicate with each other. Okay. So now this is the Docker run command to run a MySQL container. I will use it. I'll just copy and paste, and then it should do it. And so you can see this here. So it is using the hyphen network to do app. So basically, if you want to make sure that your container runs using a particular network, okay, Docker network, you can use the minus network.
I
And
have
yeah, go ahead.
to do app. That means that you have created, or that will ship within when we install Docker. I mean, what
To
is
do
that?
app. Okay, what is to do app, right? That's your question.
Yeah.
To do app is just a network namespace. I could have named it anything, but I would name it something meaningful, right? Because the containers that I'm running, going to run, it's for a to do app. Okay.
Okay. Okay. So very first command Docker network create to do app. That is what you created.
Yes.
Okay. Okay.
Okay. And I have to make sure that whatever containers that I want to run now next actually run inside the to do app itself. Okay. What are the other things that we have here? Minus v is the volume, okay, that you attach to the container, but you don't have to worry it about now. And minus e is the environment variables that you put so that you can basically set the MySQL, you know, DB password and database. Okay, but you don't have to worry about it now. But the main thing to focus here is that containers that need to talk to each other should share the same network namespace. And in Docker, how to do it is you create a Docker network, okay, name it whatever you want to name it, and make sure that whatever containers that you are going to run use the same network, okay, using the hyphen network. Okay, so let me done this. So it is unable to find the image locally, so where would it go? It will go to the docker.io to download the image and run it. Okay, so you see now it is downloading, right? and it is downloading not just a single thing, it is downloading multiple things, right? So because images are contained in layers, so they are images are as kept as stored as layers in Docker registry. So yeah, we'll talk about it later, but you can understand like it's not just one Docker you know pull, it's like downloading so many things. Okay, fine. So if I say Docker images, I should have MySQL, right? And do I have a container running? See, I have a container running, okay, with the MySQL 8.0 image and created just now. Is it now see, I'm not pretty sure that is it running within the to-do app network or which network, right? So there is a command to see, you are definitely getting some insights about the container, running container. Docker ps giving me some insight about, okay, this is the container id, this is the image command, but it's not giving me the full details. Okay, a full detail can be used, you can run docker inspect and container id, give the container id or give the container name. Okay, this name has been randomly kind of generated because we did not provide it explicitly. So, Docker just gives some random name, some arbitrary name to it. But I would typically say that, yeah, we can go with the container ID as well. Okay. So let's go with the Docker inspect. Now, in the Docker inspect, it tells you everything. It tells you everything about the running container. Okay. But we want to know about this, which is about the network. Okay. So which is the network it is using? To do app. Okay. So it is using the to do app network. We are 100% sure with this now. Now, the next objective would be if there is a MySQL application and there is a to-do app that we have to run, we have to make sure that it also uses the same network. Okay. Yep. So we don't have a to-do app, but at least we have some container, okay, which can reach the MySQL app. Okay. So, okay, let's follow this. Okay. So let me run docker exec. What does the docker exec command do? Docker exec command allows you to enter inside a machine, okay, or sorry, enter inside a container. We are not pretty sure about the docker container id. We have to copy it, paste it. Okay, this is the way to do. Let's see. Yes, are we aware about the password what we have kept? We would have it here. Okay, we are inside the database. Okay, and if I want to say show databases, I can show it, right? So these are the databases. Okay, now let me exit. Okay, now see, if there is a MySQL application and I want to basically reach out this MySQL container, okay, within the like you can basically execute some command within the container, but can I reach the MySQL container from my machine? Okay, so yeah, I think that is not possible because if I try to reach MySQL, there's nothing like that. Like if you have ns lookup, like just search for the you know domain name, just like what is ns lookup. Ns lookup gives you the ip for any domain, right? So if I try to check for MySQL, I don't get anything, right? So a container, even though container has this MySQL uh, alias, where is it? See, network alias. So basically, this container should be able to be reached using the MySQL domain name, but it can only get reached by the processes that are using the same network. Okay. So we'll create another Docker container. Okay. Using the same network. So if you see this, this is the one, right? So Docker run minus IT is for the interactive mode, but the major part that you need to focus here is the network part, right? So it is using the same network, right? And if I do this, so it will again download the image. This image, this is the image name. if you are very worried about the things I'm running, the commands I'm running, and then thinking, hey, uh, like Sada is not telling us what is the image name, what is the command, what is -it, right? I did not talk about this as well. Don't be worried. We'll talk about that later because those are very trivial. Those are like, you go Docker cheat sheet and you will get those things. But your Docker cheat sheet will not tell you about these details like, hey, the images are part of layers, right? And what are network namespaces? Like, when you want to make sure to Docker containers are able to communicate with each other. They are using the same network. So these things you will not get in the cheat sheet. Okay. So now we have it here. So if I say dig MySQL, okay, we'll get something, right? If I do it from my machine, my host machine, dig MySQL, I wouldn't get anything, right? At least you got an answer, right? But yeah, okay, maybe this is not a bit. I should use, you know, NSLOOKUP itself. So let me check if I have NSLOOKUP here inside the container. Yeah, I have NSLOOKUP here. So probably I will show you MySQL. So you see this? It detects, okay, there is a MySQL and there's an address to it. This is the container IP. If you remember, I said like when containers get created, they have their own network namespaces and everything. So they get their own IP as well. Okay. And if I do the same thing, NSLOOKUP from my machine, from my host machine, I wouldn't get any answer, right? Because it's not within the same network. So this is how you can run multiple containers connected to each other if they are using the same network. Now, this is very uh, not easy, right? This is not easy to run basically, you know, this Docker and command and using the same network. So, is there a better way to run multiple containers connected to each other without having run multiple commands? Like if I can give a configuration file, in that configuration file, I will give all the containers that I need to run, and all those containers would be launched within the same network namespace, and they can basically get connected to each other. So yes, that is a way to do it. And what is the better way to run multiple container apps that share the same network is using Docker Compose. Okay. This allows you to automate the multiple container applications. Okay. And if I have to show you Docker Compose, I can, let me just check. Do I have something already with me? Mm, I don't see so. I, yeah, I don't have anything, but I think, yeah, WordPress. Yes, this one. So WordPress site. Are you aware about WordPress site? It's a very, well-known blogging, like, uh, blog or website creation tools. Okay. So many blogs are basically based on WordPress. Okay. So yeah, if I want to launch a WordPress site, okay, let's see what are there written in the doc. So basically, just like how you create a Docker file to create a Docker image, if you want to run multiple containers shared within the same network namespaces and interacting with each other, you can use a Docker compose.yaml file. And inside that YAML file, you tell all the containers that you need to run. So one of the containers is the DB container database, where I have the image name. Image is MySQL 8.0. Okay, no, the image name is MariaDB. This line is commented, right? Okay. And what is the command it runs inside it? It runs the command MySQL with this MariaDB or whatever is the command inside it to run the database, and it does this, provides this argument to that particular command. And this is the volume that it is restart always. These are set of some environment values. Okay. And it exposes this port, but we don't have to interact with the database. That's fine. But the WordPress site has to interact with the database. So if you see the WordPress image is there, the volume is there, ports are here, and then even the port forwarding is also enabled here itself, right? I don't have to run the docker run -p command to publish the ports. The port publishing is also being done through the Docker Compose file itself. Okay. And the environment, if you see, so because it has to talk to the database, right? It needs to know what is the DB host name, and whatever is the in Docker Compose file, whatever is the service name, okay, it is used as the network alias, right? If you remember, if I show you here. So when we were creating the MySQL app, we said that, okay, if somebody wants to reach to the MySQL app, the network alias value is MySQL, right? So MySQL was the domain name for the MySQL container. Here, whatever is the service name, that is being used as the domain name, right? So WordPress DB host is DB, whichever is the service name for this. And then WordPress DB user is WordPress. You can see here as well, MySQL user is WordPress. So it has to be same, otherwise your WordPress container would not be able to authenticate to the database, right? And all these details, environment values have been passed here. Okay. Now, what I need to do here is I have to just run Docker compose up. That's all. It will detect there is a Docker compose YAML file in this current working directory, and we'll use that to launch multiple containers connected to each other because they are using the same namespace. Okay. Just a second. So it's taking time, but fine because it will take time. It has to basically, uh, pull two images. Okay, so it would take time. Let it take time. Okay, and meanwhile can take a break. You can drink coffee. So understand, like DevOps is this, right? You don't have to physically be present all the time. Okay, it's all about the mentality about DevOps. Is like you don't have to manually do stuff. If there's a configuration file which if I give it and it runs it, that's fine, right? The chances of me doing mistakes is less. The the level of focus that you need, right, is also reduced. I don't have to very much focus on the command. Am I writing this right command? Am I using the same network alias, right, everywhere? Like it's all done in the Docker compose.
Sagar, you're on mute.
Sorry. So okay, let me reiterate what I had said. Okay. uh Yeah, I was saying that whenever you are running Docker Compose up, right, it will run multiple containers, okay, within the same namespace. And to do that, okay, network within the same network namespace, not the namespace. Like all the namespaces are not shared, but the network namespace is shared. And to do that, it will create a Docker network. And the Docker network would be created using the current working directory, and it appends a hyphen default. Okay. And if I want to check Docker PS, what are the containers running? The MySQL container we were running earlier. Let me kill this. Docker kill. Okay. Now if I see, I should see only two containers running, right? So if you see, I don't get the network, you know, which network are they using. I don't get to see it. So basically I will have to, if I want to be double sure, right, I can check it using the what is the network WordPress default, right? And what is the network for the other container? It's the same. And that is where, if it is the same, they are able to connect to each other, and they will work out of the box, right? And I don't have to run multiple commands on my terminal and make sure that I'm using correct network alias and everything. The Docker Compose allows to basically run multiple containers, connected apps easily. Okay. And yeah, I want to show you that can I access the to-do app, sorry, the WordPress site, right? So let me check the cat docker compose.yaml file. Can I access it? I should be able to access it on the localhost port 80. Okay, let me see it. If I am not able to do it, we'll have to think about it. Like, am I doing something wrong? This is something different. 80. See, is it the same? I'm not 100% sure. Is it the same or not? But I hope, because I did not created this. So WordPress, it is coming by itself. So a WordPress site has been created here, and it is basically connected to the database. Okay, as well. So yeah, that's pretty much. Yeah, designed with WordPress. And yeah, I don't have. Okay, now one of the question would be, what if I want to do some operation? Okay, so can I log in? Can I do something here? Mm, okay, so one thing I wanted to know, if I kill the okay, this is the one blog we have, you know. So let me do one thing. Let me Docker compose ps. Okay, Docker compose down. I want to bring down, I can bring down both the containers, but I just want to stop one of the container, which is the DB container. I might have to just give the service name, which is DB. Okay. Now if I run Docker ps, you just see the WordPress container running. See, error establish a database connection. Okay. So basically, I wanted to prove that even though the local host is running, okay, but it's the database that is not running, so it's not working fine. So the uh, WordPress site is available, but behind the scenes, the database is not available. That's why it's getting, this error. So what I can do is I can always bring that. Whatever I have stopped, I can start as well, right? Now it works fine. Okay. So this is what your Docker Compose lets you do. Run multiple containers seamlessly connected, but understand this is only good, Docker Compose, right? Docker Compose is only good for the development environment. It's not good for the production use case. Why? Because you just saw something, right? If I want to bring down a stop a container, I can stop it, right? I stopped it. Should it restart? Yes, in a production environment, this container should have been restarted. Otherwise, your application is inaccessible, right? It's inaccessible. So there should be a way to restart this. There should be a kind of a process or a daemon which is running, and it keeps on watching the running containers and make sure that if a container dies, it also restarts that container. Okay, did you get that? Docker Compose is only good for your development environment. It's not good for the production use case. For production use cases, we'll see tomorrow. And we'll not also, like, most probably for production use cases, we will not use our machine, because our machine is not a production machine. We'll probably use a machine in AWS. Like, we'll launch some EC2 machine, virtual machines there, and basically launch containers there. Okay. So all good with the Docker Compose. Now you might have, like, I understand, like, people might like, you might have this question like, hey Sagar, you did not talk about all the, where is it, cat Docker Compose YAML, like, you did not talk about what is restart always. Okay, You did not talk about what are volumes yet. Okay. You did not talk, like there could be a number of things that I did not talk, but you don't have to worry about it that right now. Okay. And even these things, okay, you can always go to the Docker Compose. Let me show you Docker Compose. You can always find the cheat sheet and all the syntaxes, what is there for what, right? So you can always find those. That's not a problem. Okay. Uh, but the fact is, okay, why do I so to give you a gist, why we need Docker Compose to run multiple containers in a shared network namespace, and the second thing is you do not use the Docker Compose for your production use case, because if a container dies, there's nothing to restart it. Docker Compose does not take care of it. Okay, so these are the two important things that you should learn from the Docker Compose. Okay.
No, this Docker Compose is only to uh, used when we have to share the network namespace. What about the other namespace? Suppose we want to share.
Hmm. Give me a use case. Then,
I mean, maybe,
hmm. It is
maybe
possible. It is possible.
maybe shared
Okay.
some file that has to be
Yes.
accessed by both the applications.
Yes. So if you see this volume, DB data and WP data,
Okay.
okay. If I use the same DB data volume, let's say if I declare one volume DB data and use the same DB data volume and mount it to both the containers, they will be using the same file system. Did you get that?
Okay. Okay. But under
Mm.
the same network namespace, it will be shareable. I mean, accessible.
What?
I mean, right now, you have used the same network. I mean, app data. I mean, to do app, something we have used. No,
Yes.
that is a namespace for network namespace.
Yes.
Okay. Something you in the very earlier slides you have discussed about the many different namespaces, right?
Yes.
My question is, whatever the demo you have showed, that is only to only upon the network namespace. Suppose you want to do the Docker Compose with the other namespaces, means then this is the same steps we need to follow, or
So whenever you want to run multiple containers connected to each other, okay,
okay,
you go with the Docker Compose rather than launching each container, creating your own network, right? Docker create network and basically running the Docker run command to run the container within that network, right? So better go with the Docker Compose file.
okay,
Okay. And the thing about, like, so what you are asking is the right question, but maybe it's not the right time for me to answer it. Okay. I understand that your curiosity is about if the network namespace can be shared. Can't be the other namespaces be shared? Yes. Do we have a use case for it now? No. Okay. Did you
okay,
get that?
okay, okay,
And is it being done very, like I would say, yeah, definitely. There are other namespaces being shared a lot. There is a place where in Kubernetes, when we go into the Kubernetes, I'm not very sure that if we will be able to reach the Kubernetes in this tomorrow, but understand in Kubernetes, all the namespaces are shared between containers. Okay, there is a, like, it's a typical design choice where you can run multiple containers within the same shared namespaces, like all the namespaces, network, VPC, like network, user, and all the namespaces are shared. Okay, so yeah, it's a common practice, we do it, but right now I don't have the use case, so not showing you. Okay.
okay.
Okay, let's go to the next session. So yeah, if you want to ask me anything now, you can ask me. Already you have asked one thing, but yeah, you have further questions, you can ask me right now. I will give a five. Okay, let's give a 10-minute window. You ask, you either ask or we take a 10-minute break because anyways, it's 11:25, right?
I don't have any further questions right now.
Okay. Vamsi, I see you coming in, coming, going
Yeah,
out. So
yeah. There's
yeah.
a power cut. Like it's raining here at my
Mm,
place, so there's a lot of power cut. Even my phone signal is not good, that good to connect. So
Mm,
I tried multiple times. So that's what. Okay, fine. So this is an off topic. So I just want to understand,
mhm.
like, what is the monolithic and microservice architecture? What is the difference between them? Like when we use monolithic or microservices? Because this is something like which, on top of my head, like which I want to understand better.
Hmm. So earlier there was, let's say, a ticketing system, IRCTC site. Okay,
Mhm,
let's take an example, IRCTC site. If the IRCTC site is only just one server, okay, you can run inside it the front end app. Okay, inside itself you can run the back end app. Inside itself you can run the DB as well, right?
mhm,
Okay, but now but now the application, let's say Flipkart.com, right? Flipkart.com is not a simple website, right? It might have different applications running within inside it. Okay, one for the orders. Let's say one is for the orders, handling orders. One is for the user info. Okay, one is for the cash on delivery. Okay, one is the payment gateway. Okay, you can break down your application, single application, into multiple, you know, uh, applications, and each applications now, because they are independent from each other. Let's say your cash on delivery app runs on Python. Okay, your payment gateway runs on the Java. Your user related application runs, on Golang. Okay, so each are now able to basically use its own programming language, use its own resources, everything, right? So basically, what is microservices? Microservices is breaking down of one single service into multiple parts, right? But still, these order service, service will need to interact with each other, right? The payment service might need to interact with the cash on delivery service, right? So probably there is to be some way to have that inter app communication, right? This can be over HTTP, this could be over socket, this could be anything, right? Microservices does not say that, hey, two services need to talk over HTTP only. It's just a way that you do it, right? So it could be a socket connection, it could be there was a remote procedural call. Okay, it's just that different services interacting with each other, and all these services interacting to make a big application, right? Together create a big application. There's a, like, you can see there's a severe advantage here, right? If you want, you can definitely have it in as a monolithic service, right? But then let's say your payment service can be, let's say you have created your application in Java, right? And your payment service is something that you know that it is better to be written in Python, right? But because your whole application is already in Java, you have to, by hook or crook, you have to make sure that your payment service is also, running in Java only. You can't use Python. You don't have that liberty now. But if you are into microservices architecture, you can say, okay, fine. Most of my services are in Java. But if I think that a payment service should be written in Python, it is easier to maintain. It is easier to handle. Everyone is basically writing their payment service in Python. Let me go with the Python, right?
Um, I'm sorry, like I still can't get it. So basically, I'm just trying to understand the use of microservices. So okay, so my question is, like, what if, like, if we add the load balancer in between the monolithic architecture, and it will does the same thing, like, what I understood from this. Now, let me.
Mm, yeah, I can tell you load balancer part.
No, no, no.
You can.
Yeah. Uh, from the concept you
Mm,
explained, what I understood is, like, you're trying to reduce the traffic between by segregating different segments in the same app sections. Like for payment related services, the microservices will route all the traffic to the payment, uh, you know and leaving the other sections as is without having much burden on those. Is that what it means? Because it seems like, this is what my understanding. Please correct me.
so you are attacking the problem through a system admin, mindset.
Hmm.
What it is required to achieve microservices. You are like attacking through it. I'm saying, why is microservices needed at first place? Microservices is not needed at first place to reduce the network traffic or any of the infrastructure related stuff. Okay,
Mhm.
did you get that? It's mostly on the development side of things. So the developer choice, developer freedom. Okay, did you get that? It's like the system design, not a system design. It's more around application design, right? So does the order related stuff needs to be written in the Python same programming languages as the payment related stuff? If you are using a monolithic service, you have to go that route. Like you have to use the same programming language, right?
Mhm.
But if you are using microservices architecture, your developer teams can say that, hey, we have been using Java for all the applications, right? But for the payment, we need Python application. So why not we create another service? And how does that service interact with other, like our main service? It can interact using the HTTP. And this is how you actually, from a monolithic service, you break down multiple microservices. Okay. Now, in the current scenario, many of the teams are so mature, they are directly going and attacking like they are not saying that, okay, we'll first create the monolithic service and then segregate different parts out of it. They are directly saying, hey, let's begin with the microservices architecture, right? And
Mhm.
it's nothing to do with network traffic and anything, or like it's not related to the systems or infrastructure. It's not solving any infrastructure related problem. Maybe it is adding to it. Okay. Going with the microservices architecture might even add, I would say, might even add complexity, okay, for the infrastructure person, but it is simplifying the freedom of choice for the developers and separation of concern as well, right? So a payment team, okay, development team just needs to focus on the payment related code. They don't have to think about the cash on delivery code or order related code. If all the code would have been together within the same application, any mess up that the order team would do would also impact the payment team because it is the same service, right?
Mhm.
So yeah, it's the separation of concern. It's like freedom of choice. Okay, for the developers, for the infrastructure person, it means more work. Okay, it's not solving our problem. It's making it far more complex, but it is actually solving the business problem, right? If your user service goes down, at least your payment and order service are still intact, right? Because they are a different microservice.
Okay.
So yeah. And Docker does really help you to solve that problem. Okay. Uh, of the like the microservices invoke some problem for infrastructure people running multiple app, like rather than running a single big app, we have now to run multiple small apps, right? How do we manage it? How do we isolate it? Using containers. How do we manage containers? Using Docker. So yeah.
Okay. So my another question, which is an off topic, like what is currently CI tool or CI/CD tool running in the market, or maybe asking by many interviewers, or maybe implemented by many orgs? Is it just Jenkins or GitHub Actions or GitLab? Because like
Mm.
for uh, in my current role, I'm using a legacy product, TeamCity, but no one in any other company uses it. But it's still a good product as per me. But I just want to see like what other companies and the market trend is going on. Is it Jenkins, GitHub Actions, or GitLab? Because I've seen a lot of content over there which overlaps with this. I just want to take your feedback or maybe your experience.
See, TeamCity I also used.
Hmm.
It has been 3 or 4 years back, and yeah, I agree to you. I agree with your point. Like it's just one client is using, so we are using. We are not very sure, like if we will be using it everywhere. Okay, so but today the market leader for CI, because even this Jenkins is legacy as well. Okay, so Jenkins is a legacy CI system, but still it is having its like fair share of most of the people go with this. but the new ones have come up. Like any new company that comes, they think about like, let's use GitHub Actions, or if they are having their repository on GitLab, they are saying let's use GitLab CI. That's all. Did you get that? The companies who are already existing, they want to go with the legacy tool, they go with the Jenkins. Any new people, new startup being found, and new team, like new work is being uh, you know designed, or new, what do you say, new initiative, right? So they are going with the GitHub Actions if their repository is on GitHub. If their repository is on GitLab, the code is on GitLab, they are going with the GitLab CI. So it makes sense to tackle all these three
Okay.
with this on priority. Okay, Jenkins on priority. Get and see, whatever is, I would tell you what is the priority. Priority is you doing the next task, right? Like if your goal to learn DevOps is to switch into DevOps role, okay, you probably would go and search on the LinkedIn what are the job listings, and do they ask Jenkins, do they ask GitHub, do they ask GitLab CI? Tackle that if it is the company that you want to go into, right? If it is in the same company, you are in the same company, you know very well that in one of your team, okay, Jenkins is being used, and you know that if you show the case your capabilities that you know very good Jenkins, you can probably land in that team. Okay, so yeah, go with the Jenkins, right? So it depends on the context. What is your next step that you want to take? So yeah, so it depends on that. So let's say in your team, right? Like in your place, you are using Team City. You are very well aware that okay, in your current project you are using it, but might not be used everywhere. Now, if you also don't want to switch the company as well, right? So you probably would see like, hey, what are the other teams in my company using in other projects, right? Probably I will go with the GitHub Actions, right? Because I know if I learn GitHub Action, probably I can chip in to the project manager that, hey, please, take me because I know GitHub Actions, right?
Hmm.
Otherwise, if you go with the Jenkins, then you probably like, but in your current organization, nowhere is Jenkins being used. So it typically means that you want to switch now, right? That's why you are learning Jenkins.
Yeah.
So
In my current company, like they were using all the CA tools. Like as we acquired a lot of companies, some products are using Jenkins, some products are using
mm,
City, some are using GitLab, GitHub Actions, Circle CI. I mean, you name it, we
mhm.
have those. Okay, I just want to see, like, if I want to stick, like, next 5 years or 10 years, like there may be many lot more tools coming in, but as a standard, like, Jenkins is per se staying in the market like for almost 10 plus years, to my understanding. So, like, I just want to see, like, there are a lot more features coming in. So I just want to stick to one tool and maybe go through it, uh, because I'm just starting to upskill myself. So, so
10
I'm
years. I would not be so hopeful about Jenkins because if things change, they change very fast. So
yeah,
you get that, right? Like I definitely, there's no denial that Jenkins is the most CI used tool right now. But there's also no denial that GitHub Action and GitLab CI are growing at a very huge
yeah,
space. Okay, they're going very upward. Like most of the new teams, they are forming new projects. They are going with the GitHub Action, GitLab CI. That's all. They don't think about, oh, okay, let's launch Jenkins server, because you understand, right? GitHub Action, GitLab CI does not ask you to launch a GitHub Action server or GitLab CI server,
yeah,
but Jenkins does, and that means that is an overhead, right, to manage. So
yeah. One more question, like, I'm hearing a lot about platform engineering. So, what's the difference between a platform engineer and a DevOps engineer, and what exactly those two guys will do it?
I will answer it maybe in the later section, but yeah,
Mhm. Okay.
if you have any other question, you can ask. Otherwise, I will definitely take care of this question, but at the end of the session.
Yeah, that's it from my side.
Okay, fine. So, interesting questions. I will answer at the end. Uh, and before that, I want to make sure that I close what I have started. So you have seen Docker Compose till now. What is the next thing that I had planned? So I had planned one more thing. What was like, this is the Docker cheat sheet PDF, right? Because you have seen me running some Docker commands and everything. See, it would be very hard for me to show you each and every Docker command. It's better you go to the cheat sheet and practice on your own. Okay. And I understand you might have confusion, you might have concerns, you might have some questions. That is where I'm asking you to go and try it out, and so that you have a better questions and you can ask, come back to me and ask, hey Sagar, tell me what is image prune, what is this, like whatever you have figured out. Like you might run this docker exec minus it command and then might ask me, hey, what does it means stands for, right? So I better want you to start exploring and then ask question rather than me, spoon feeding you. Okay, because even that would not work, I know that, because it's not a concept, right, that I can spoon feed you. It's the commands that you need to run and you need to understand. Okay. So this was there. Now the next section was Docker images, right? I talked about the Docker images, but I want to talk much in depth right now. Okay. Already we have seen Docker images. What are Docker images? Docker images are the blueprint to run your container. And the container image is what is the Docker image? It's a standardized package that include all the files, binaries, libraries, and configuration to run a container. Okay, it's all has all the prerequisites. Okay, so for example, if you want to run PostgreSQL, will have the container. It will have all the dependency. It will have all the config files. It will have the database executables, right? Binaries. If it is a Python based application, it will have the Python dependencies, app code, and even the Python installed, right? Python runtime. Okay. What are the two guiding principles when creating an image? So images are immutable. If you create an image, you can't modify, you can't go inside it and modify. If you do try to do that, you will probably end up creating a new image. Okay. So the existing image, once an image is created, you cannot tweak a file and modify and take a file out. Okay. You can create a new image on top of it, but a particular image stays as it is. Okay. And the second thing is containers images are composed of layers. So when you see a image, okay, Docker image, MySQL, if you remember that it was pulling the image and it will pulling like multiple lines of, pull progress bar was there. So because it was pulling the image, but it was pulling the layers of it. Okay. So a Docker image is contained of the layers. Okay. Now, what does that mean? What does the layer mean? So, for example, each line in the Docker file, okay, because a Docker image would have been created using a Docker file. So each line in a Docker file represents a layer. So first line is the bottom layer, okay, which is the base image, right? Like it's saying that, hey, use the Node.js. Like I want to create a Node.js based application. So use a Node image. Okay, so this is the most bottom layer. So it will use the existing image, and on top of it, it will create a work directory / app. It will copy your code inside the app directory. It will run the yarn install, and then it will not do this. Like this is the top layer, but this comes into picture when the container is running. Okay, this is not the part of Docker image. So this is the command it runs when you run the particular image. Okay, and the topmost layer, okay, this topmost layer, all the other layers were what? Because they were part of the image, they were read only image, and they were immutable, and you cannot write anything on top of it. But when a Docker image runs, the top layer is the container layer, and it is a write, like you can mutate it because you can create files, whatever you do inside a running container, it gets append, like you do it, and you do it on the top layer, not on the lower layers. So the next time somebody creates a new Docker like container, they will not see your changes. Okay, did you get that? So if I want to show you, so let's say Docker PS. Okay, so I have this Docker container. Can I run Docker exec minus it and then container ID? Right, there's a container ID for this. Okay, and I want to run this sh command, and let me see what are the files. Let me touch a file. Let me create a file basically. Echo hello file.txt. Okay, a file has been created. File.txt. Yes, a file has been created. Now let me exit. Okay, if I again, enter inside the container, what you would see, ls grep file.txt file. Like I want to just check. Just sorry. ls grep file. I want to check whether this file exists. Yes, a file exists, right? So understand whatever changes I am doing, it's on the topmost layer, okay, of a running container. I'm not basically doing any changes in the Docker image. So what does it mean? It means that if I run another Docker container with the same image, okay, Docker run minus it, okay, ls grep file. You don't see any file right here. Why? Because whatever changes you are doing on a running container, you are doing on the topmost layer. But if you are using an image, you are using only the layer like till layer 4, right? Because that was the part of the image. Whatever changes you are doing on the topmost layer, and that container is different from the another container, right? You might be using the same image, but it's a different container. So whatever changes that you do inside a running container stays within that container. It does not get, basically injected into the image. And that is where if I create a file in one container, it's not, you know basically baked into the image. And another container, if it runs, if I run another container with the same image, I don't get to see that file, because that file exists on the topmost layer of the running container rather than, going inside the image. So if you have, let's say, for example, okay, let me just do this. So what do I mean typically is this. If I have this image, okay, 1 2 3 4, I run a container out of it, c1, and I make some changes. Any changes that I do is on the topmost layer now, okay. Any changes I do is on the topmost layer. But if I try to run the new container, okay, it will use this image rather than, using your this container one container, right? So basically it has only 4 layers, so it does not get to see the changes that you did in the container one. So any changes that you do inside the container does not go back to the image. So image is pristine, okay. So yeah, and now you might say like, hey, you are saying this as a top layer, but it's
Hello, Sagar, you are in mute. Hello. I'm not able to hear you. Hello, can you hear me now?
Can you hear me now?
Yeah, yeah, I can hear you now.
Okay, I think there's some issue with my mic, maybe. So, okay, if I was on mute, I'm not sure like how much did you get it, but it was very important. Did you get like, okay, these each line forms a layer?
Yeah, those things I was there. I mean, in top layer, whatever that is not go to the image is pristine. That was the last sentence I heard.
Then it's all good. Okay, then. Uh, so I was drawing some pictures here. Did you get that? Like I was showing, like, container C1, C2. I hope you got that as well, right?
Yeah,
Hmm.
it was there.
Okay. So then, yeah, that was there. And yeah, I was trying to say here that don't worry about, like, if layer 5 is the top layer, it's at the bottom, right? Just think about, like, you can visualize it like, okay, so this line forms the base layer. This line forms the above layer. Okay, this line forms the above layer. It's just that because I had to make, like, each line correspond to each layer, that's why I have kept it like this. Okay, did you get that? Okay, yeah. So the next time, if Docker images are consisting of layers, so the next time you create a Docker image with some different code, okay, what would happen? Layer 1 would not get recreated. Why? Because already there was a Docker image that got pulled, right? And it will have the layer 1, like, layer 1 is existing already, right? So it does not, like, the next time you build a Docker image for another Node.js app, it will not try to build this again. It will not try to pull. It will also not create a working directory as well, right? Because it already exists, but it might copy the code, right? Why? Because it's a new application, right? So probably the code would be different, because layer 3 has to be built again, okay, because the source code is different. All the subsequent layers, okay, will have to be executed again, even though it has been executed earlier. And it makes sense, right? If you have changed the code, you might basically do the uh, let's say pip install requirement. Let's say you change the package.json, like dependencies, you change the dependencies config, right? So probably you would have to run the dependency installation again, right? So Docker can, while building, will use cache until and unless it sees that, okay, the earlier cache is, the earlier layers are okay or not. Okay, for example, let me show you one thing. Okay, let me show this so that it becomes more clearer. uh is this cd hello world, right? If I do a Docker build now, Docker images, right? Okay, if I do a Docker build this, right, version 1.0.0, see, it brought everything from cache, right? Because already we had, so Docker keeps these layer stored in its cache. So if you're trying to create an image, because it most of the things is not changed now from the earlier image, when we created the earlier image, it says like, hey, everything is fine, so I don't need to recreate the image, bring everything from the cache, and that's all, right? Fine. We have hello world version. Now, let's say we are going to change some file in the hello world.py, right? And let's change something. Let's say, hey, we want to just, rather than hello world, I want to have hello world, right? Without comma. Okay. Now let's save this file and let's create Docker build this. Okay. Now what you would see, just a second. Did I close it abruptly? Hmm. Okay, let me do it again because I think I closed it abruptly. So hello.world.py, let me change it to, let me add some, exclamation mark. Okay, and let me call it Docker build. Rather than version 1.0.0, I will call it as version 2.0.0. And now you see that most of the things happen through cache, right? But the last step did not ha happen through cache. Why? Because, and even it did not take much time because it was just a copy, simple copy. But you see that all the earlier commands, right? I can show you cat docker file. See, From platform did not change because we are still using that same Python. Copy require, we did not change any changes in the requirements.txt. So it happened through the cache. It got picked from the cache. We, because this did not change and this command is still the same, it also ran from the cache, but we changed the hello world.py. So at that time it missed the cache because it says, hey, hello world.py got changed. So probably I would have to recopy some new files inside the image and not use the same image, okay, or use the same layer. Now I can show you one thing. If I change the Docker file itself, right, I change the copy requirements to, okay, so in this, rather than Linux AMD64, if I change this ARM64, what would happen? And I try to build it, Docker build version 3.0.0, right? What would happen? What do you think? Which are the files which will be built from cache and which are the lines which will be built from, scrap? Like, which are the lines will be built and which are the lines will get, picked from cache? What do you think? Can you answer?
I guess everything built fresh.
Yes, yes, exactly. Because the first line got changed, because of it, the next line has to change. Because the next line does, see, Docker does not know automatically that this has to be run or not. It does not know whether the requirement.txt got changed or not. But it knows one thing. It knows that the earlier layer got changed. So if the earlier layer, if the parent layer got changed, the next layers would be rebuilt, right? So if I run the Docker build version of this, we'll see, it is not getting it from cache now because it's the different platform. I'm selecting a different platform image. Or if I would have used Python rather than latest, if I have used version 3.12 or 3.10, still it would have basically repulled the image from, like, pulled a new image, and because the image is new, all the next steps have to be re-executed. I will give one more example. Okay, now let me change one thing. Vi requirements.txt. Now tell me, I have changed requirements.txt. Okay, if I do the Docker build, what are the lines that will be built from cache, and what are the lines that will be built?
First layer will be built from the cache.
Hmm.
The second layer is also fine, but the PP requirement, no, copy requirement.txt, that will be from fresh.
Hmm. And what about the next step?
That will is also from fresh.
The next step also. Yes, exactly. So that is what I wanted to mention. Docker is fast. Why? Because it stores all the Docker images in layer. Like the build process becomes fast because it uses the caches and it stores the Docker images in form of layers. But whenever it sees that a particular line, a particular layer misses the caches and it has to be built new, so all the underlying, all the layers, after it has to be built from this fresh. Okay, so you get that? I think you got it because you answered the question correctly, so you got it, and that is very important. Okay, why? I will tell you. A lot many interview question is about how do you make a Docker build process fast, right? Okay, interview questions are how do you, what are the best practices to build a Docker image, right? So most of the Docker building image best practices rely on the fact that you already know. So basically, sorry, let me rephrase it. Most of the best practices to build a Docker image, okay, to reduce the build time, to make sure the Docker images are very less in size, okay, is all dependent upon how you place your lines in the Docker file because it affects the layers. Okay. So a bad way to write a Docker file, okay, would be to remove you. to basically, okay, a bad way to write a Docker file would be vi Docker file. If I move this command, copy hello world.py to just after the base image, that would be the worst way to write a Docker file, because you want to make sure the frequency of the changes that you are injecting into the Docker file has to be the least on the top and the most on the bottom. So if you move this hello world.py at the top, what would happen? Mostly what would happen is like very frequently you will change your source code, right? Hello world.py. That would mean even if you do not change the requirements.txt, you but still it will run again. It will again run the pip install requirements.txt and it will take time. So most of the time it does not need to do it because it's just a source code change and not a requirements dependency change. But because you have placed your copy command on the top, okay, copy source code command, not the requirements.txt, it means that anytime you do a single line of change or single character change in your source code, your image has to build from fresh image whole, like it cannot use the cache at all, right? So most of the best practices related to Docker building process are based on the fact that you understand how does the Docker images layers work. Okay, did you get that? I can even show you, like it's just that don't Docker best image building, and people do ask in the interviews. So where where is it? See, image building best practices. First of all, they are saying that, hey, do you understand image layer? This is how images are layered. So layer caching and multi-stage build is something different. But yeah, I'm not image best practices. It is definitely giving me only one answer, but I think there are multiple answers to it. Yeah. So yeah, choose the right base image, right? So if you are building a Python app, choose a Python app rather than using some Linux image and then installing Python on top of it, right? And where is it? Where is it? Yeah, leverage build cache, right? When you build an image, so basically this is the place where most of the things here, okay, tie down to you understand what the Docker file means, right? And how the Docker file represent each individual layers in a Docker image. Okay, so that is there. And I've not talked yet about the Docker ignore, but we'll talk about it later. But yeah, understand, if you want to understand about Docker ignore, just understand, if you know about git ignore, what does git ignore do? Yeah, see, they have even suggested, right? Like this file supports execution patterns similar to git ignore. So it's just like, okay, if you don't need some files inside the Docker, you can say docker ignore. So it will not basically build, like, copy those files inside the Docker. And so your Docker image would be far less than what it was earlier. Okay. So any readme.md files, right? For example, let me show you. Here I am copying hello world.py only. I could have copied the whole working directory, but do I need the whole working directory? No. And what would happen if I put the whole working directory inside my container, the Docker image? It will basically bloat up the size of the Docker image. So I didn't want that. So I just only copied only the files that I need inside the image or the running container. Okay. So those are your best practices. Okay. Uh, what else is left? Yeah, that's all I had. Do you have any questions you can ask?
No, no questions.
Okay.